Note about this, and since this is being recorded, this will be the opening. Since this is WA3007 developer Kubernetes for developers, just know that I will be recording the class. The recording is controlled by me and is not used for any other purpose than just to be shared with you. So it's not reviewed by anyone, not looked at. If you feel like you say something, you're like, Michael, I absolutely don't want that, because it's, whatever, private to the company or whatever, just note the time and let me know and I'll edit it out. But otherwise, it's just shared with the three of you in a private unlisted link on YouTube. So, okay. All right, let's get into this. Okay, so a little bit, I'm going to just like set a few little pieces of context, right? Now, things that are kind of nice to know, but aren't essential is that you probably are aware that Kubernetes is Greek for helmsman or, pilot or leader or governor. The word gubernatorial or governor actually comes from the Greek word Kubernetes. The three gentlemen, Beda, Burns, and McLucky, who started this whole thing, are engineers who work for Google. Brendan Burns in particular, who I've met, cracks me up because there's an old video of him screaming into hard drives back when everything was mechanical, like, disks, like platters, because he's the one who found out that vibration in data centers was actually killing disk performance. And of course, manufacturers shifted how they produce disks after that point in time. Kubernetes, as you're aware, is referred to as K8s because people get tired of typing in the long name. And, its main function is simply to allow you to deploy, maintain, scale, all the stuff. It's a container orchestrator. That's what it's for. Whereas Rancher, for example, is a piece of software that can manage Kubernetes, right? Same with like Docker Swarm now, right? Docker Swarm will manage Kubernetes. Really, Kubernetes is a container orchestrator, and it's published by the CNCF, the Cloud Native Computing Foundation. And this is probably important for you to know. Let me bring this up really quick. The CNCF basically is a consortium of some of the strongest tech players, right? The idea here is that the CNCF's job is to basically shepherd software that makes the world cloud native. So as you can imagine, it's got Google in there and Microsoft and Amazon. And the idea here is that how do we make it so that these open source projects are governed, shepherded, and matured in a way that takes us into the next generation of software? Now, I'm going to simplify this because these kind of like modes here are really overwhelming. But here's a link, by the way, in chat if you want to kind of save it for yourself, which I recommend, actually. So here, if I just actually take it and say, look, I just want to see all the graduated projects, this is where you start seeing like the power of the CNCF and how they shepherd open source projects. Kubernetes is down here. You can see that other things like that no one really knows about, like Vitess and TICV, which I'm not even sure how to pronounce that because I don't even know that I use it. But notice that etcd, Core DNS, Envoy, Helm, Linkerd. By the way, Linkerd and Envoy are core components of Service Mesh, Envoy in particular. There's Containerd, which is you're going to hear again because Containerd is a supervisor. Rook is a storage system, and then Harbor, OPA, and Tough are kind of like add-ons, basically, either for security or for managing containers, like a container registry for Kubernetes. Notice also that Prometheus is over here under observability analysis, as is FluentD for logging and Jaeger for tracing. The reason I'm showing you all this is that, these projects are basically the cutting edge tools that define, what's going on in the industry. As we add this down to maybe incubating projects, things get even more interesting because Argo CD, by the way, is here, as well as Flux, Emissary, Contour, like gRPC, like all the stuff that is not even necessarily bleeding edge, although some of it is definitely on that line. This is the group that shepherds these technologies and pushes them out to the world. So be aware that if you're ever looking for, well, what is the next skill I ideally would be acquiring, it's pretty much something along these lines. Whatever these people are focusing on is pretty much what the entire industry is focusing on for the most part. So Kubernetes fits in here because pretty much all of these things are wrappers around the core of Kubernetes, right? either a database that runs, that supports Kubernetes, observability tools, tracing tools. And while it's still about applications that run on K8s, K8s is the focus, right? K8s is the core of this kind of thing. So the CNCF, you want to keep an eye on those guys. So since Kubernetes is an open source tool for container orchestration, it's easily scaled, right? Can be implemented in a variety of different scenarios. They've got small versions like K3s, who short name I can't remember. But all it does is it does require an operating system. So Kubernetes just requires an operating system run. Primarily that's Linux. Obviously Windows Server 2019 supports Kubernetes as well, has a host, like as a worker node, but it doesn't support it as a controller or a leader, or sometimes known as a Kubernetes master, right? So just know that when we're talking about Kubernetes, we are definitely talking primarily about Kubernetes on Linux. Kubernetes on Windows is a slightly different beast, and it's very different from Microsoft's implementation of containerization. So, when they start talking about Hyper-V isolation and all these other things, it's a little different than just straight up Kubernetes implementations. Do note that at present, the Kubernetes open source team has no plans to convert the controllers or leaders for Kubernetes over to Windows. So while they will support a mixed cluster with both Linux and Windows nodes hosting those applications, the controllers or leaders will all, at present will be Linux. Some will say always be Linux, because we'll see how that goes. Now, since it's mainly a container orchestrator, and we have an idea what that is, because that's just deploying and self-healing and scaling and et cetera, just know that, typically this is considered to be a good partner with things like microservices, right? So as we slice things out into smaller and smaller services that then can scale independently, the container model works really well. But let's be frank about this. There's no size limit for the size of a container that you can run. So, if you got a 128 memory resident gigabyte container with 10 terabytes of storage required, you can figure that out, right? It's not even really hard, frankly. It just depends on the size of the host you're using. Now, here's an interesting diagram around like basic concepts around how Kubernetes is set up. Now, as you know, we got the Kubernetes master, also known as the primary or the leader. And what happens in this kind of scenario is you usually have at least one. If you're in production, you usually have three, usually not necessarily more than three. Depends on the three nodes that you're using as masters, right? But you have at least one master, and the master's job is to basically connect and control and manage what's going on with these nodes over here, right? As delineated by the double arrows. What's interesting, by the way, is that, you could add as many nodes as you want to Kubernetes. You just need to make sure that there's plenty of network bandwidth and that the masters are not getting overloaded with management, right? Does anyone know off the top of your head, like what the limit is for just a standard Kubernetes installation for the number of worker nodes that you could have inside of a cluster? Does anyone know off the top of their heads? I asked because it kind of blew me away. Someone know?
I think I have heard, I don't exactly remember the number, but I have heard like it's in the thousands.
It is in the thousands. It's right now, I think as of like 121, which I think we're on 123 now. It's 5,000 nodes. And by the way, I didn't know that. Last year, the NFL asked me to do a proof of concept for them. They needed a 50,000 pod, basically, container environment. I didn't know that you could actually stick 5,000 nodes in there prior, because quite frankly, I knew it was in the thousands like you, Vinod, but I just never thought to figure it out, right? I went and looked at the documentation. They're like, yeah, we can support 5,000 nodes. I was like, really? I found out it really actually can support 5,000 nodes, because we got pretty close with the NFL. So just know that you can add as many worker nodes as you want. The worker nodes can be mixed. So if you want them to be Linux and Windows, because you've got, containers compiled for Windows and you've got containers compiled for Linux, you can mix these up. So no issue there. Now, so you've got the data plane which, I'm going to divide with this little blue line here, right? So you can, or actually, you know what? Let's choose pink. I'm going to divide here is that, on the left side of this pink line, that's known as the control plane. This is what we're referring to with the masters. So if there's like 5 masters or whatever, that entire set of 5 masters, those are the control plane. Everything on the right that's actually running the actual containerized applications, those are known as nodes or worker nodes. That's the data plane. So when you hear someone say, I'm having issues with my data plane, what they're saying is they're having trouble with all of the workers, the nodes inside Kubernetes. If you hear someone say, I'm having issues with the control plane, they're talking about they're having issues with the masters, right? Now, the master itself, like that single box, has a number of components on it, like a scheduler, an API server, etcd. We're going to talk about those pieces just a little bit, but just know that everything here is API driven. So Kubernetes is constantly talking to itself and to the systems it manages, all through an exposed API over a single port. So just know that all of this is API driven. Everything in Kubernetes, like everything in cloud, is API driven. So it's all happening via APIs. Even internally in the masters, like etcd, the database that runs the back end, is talking to the scheduler through an API server. Scheduler is talking to the cloud controller through an API server. The scheduler is talking to the software on the nodes through an API server, which in turn is then talking to the software that's on the actual worker nodes. So just know it's like APIs everywhere. So just so we're clear about that. Now, one other thing to note here, which might get repeated later, is that pods are the fundamental unit of deployment inside Kubernetes. Pods are not containers. Pods are just the fundamental unit of deployment, meaning whether you're doing a stateful set or a deployment or a cron job or a batch job or I feel like I forgot one, a daemon set, which are the different workload types inside of Kubernetes. Regardless of what workload type you're running a pod underneath that. And inside that pod is typically one application container, typically, and that's the best practice that's recommended, and one or more security or operational containers. What do I mean by that? In other words, you got a Java app that you've launched and you might need to collect the logs off of it. You might want to put a firewall in front of it because you want to connect it with other firewalls and have a huge like security mesh of some type or service mesh, right? You might put those little extra applications in with the primary application and then put those in a pod so they'll all scale together. Now you might say to yourself, Michael, okay, why, just to say this, like, what if I had a data, what did I just stick my database? Like, what if that little pink dot that I stuck in there was a database? Here's the problem. Let's say that all 3 of those pods were all the same application. And the only problem I was having is that I wasn't having a problem with the database, but I needed to scale this little like green part, right? So where the application is. Like I just needed to scale this guy. I didn't need to scale the database. What then ends up happening is that I then have to basically scale the database. I'm forced to scale the database at the same time as I'm scaling the application because it's now included inside of the pod. So just as a general statement, we are still architecting our applications so that they are loosely coupled and we are not scaling components unnecessarily. So in that pod is typically only one application container. If that application container is a database application, then it goes in its own pod, right? So as you can imagine, just to clarify that, to make sure the concept is clear, let's say, I take out the database away from this container, and instead what happens is I'm going to put the database down here. And so that's actually, this application is actually a database. Now, do I need 3 of them? Probably not. Maybe. Probably need at least 2, right? And so what happens then is that the application containers, right, are going to talk to these databases, usually through some kind of abstraction layer, like a cluster IP or something like that. And then that in turn will talk to the database on the back end. Okay. So just remember this concept. Pod is the basic unit of deployment. Inside every pod is usually, not always, usually one application container. And again, the question that you need to answer about what's in that pod is how do you want to scale it? Do you really want to scale your app into your database at a 1-to-1 ratio every single time? Or do you want to keep your database constrained to maybe 1 primary and 2 reads, and you're going to scale your application to, from 2 to 100? So remember, the question that you always ask yourself is, do I stick this in the pod? Is how am I going to scale this? If you're going to scale it independently, it doesn't go in the pod. If everything needs to scale 1-to-1 together, it goes in the pod. Does that make sense to everybody? Any questions there?
So I have a question. So what would be the best practice? Let us say you have this in the, in the application, your application pods, let's say they are, can you hear me, by the way? I'm not using
Yeah.
the.
No, I can hear you. Yeah.
Okay. So let us say, sir, your application pods are like web-based applications, and they need to talk to database, let's say, to save the data to a database. So is it, sir, so what would be the best practice? Let's say, and the database, let us say they are, MySQL database, or if we are running this in the AWS cloud, that could be RDS, for example. So what would be the best practice to use the RDS from these applications?
Yeah. And, just to say that, Vinod, I actually am a proponent of, in year 1, don't run any database applications of any type in Kubernetes. I'm just going to throw that out there. Like when you get started, ideally, if you cannot run data stores inside Kubernetes and just keep everything stateless, usually 6 months to a year, that's a great way to get teams comfortable with Kubernetes without introducing the complexity of a data store, right? So in this particular case, to answer your question, let's say that, our containers are looking to talk to an external database, and let's keep it in pink, right? Because that's where we were. So let's say in this case that you're using RDS, and so you've got the relational database service, and this is on AWS. It's like this whole thing, like if I put a box around it, this whole thing is actually on AWS, right? And so this pink one right here, that's RDS. So we're not going to mess with that. We're just going to, that's, you're not even going to be able to see that. That's funny. Why would it do pink? Because I chose pink. And so here we are, RDS is there. Now, what will usually happen is that, and by the way, you can actually get Kubernetes to create the RDS database for you if you actually enable what's called the AWS controller for Kubernetes. You don't have to do that, and it really just depends on your model for deployment. But if you're doing everything in Kubernetes, that might make sense. Now, what would happen in this particular case is that one of the ways in which you can expose applications is to use something called an external DNS name. And in this particular case, you might actually get all of your pods that are running your app, and let's say it's this one right here, you might actually get all of them running your app to actually write out to what's called an external DNS name. And what would happen is that external DNS name would actually redirect from a Kubernetes standpoint over to RDS. And so in that particular case, externalizing your data off of the cluster until you feel super comfortable to deal with that is great. But I got to tell you, when you're on a managed environment like AWS, there's actually no reason to actually bring your data stores into Kubernetes, because the latency is like single digit millisecond usually, right? So there's actually no compelling reason to bring state into your cluster if you're on a managed service provider like, Azure, AWS, or whoever. But that's how you would do it, is you use an external DNS name. And what would happen is that the pods would actually talk to that name, and then that would then redirect them to RDS. The reason for doing that, by the way, is then you can actually switch the databases easily without having to go in and mess with configuration for the pods. Otherwise, you might have it resolved inside the application configuration, which is another way you could solve it. But mainly by doing that, you can actually just control where it goes once it leaves the Kubernetes cluster.
Sir, could you dwell on the external DNS a little bit?
Yeah. So let me go pull up the Kubernetes documentation on this, because it is actually really good. Hold on. Let me clear my drawings out and make sure I can actually click on something. Let's see. Let's go look at documentation, and let's talk about Yeah, so when you like publish a service, there should be a section here for defining it in a certain name. So let's see here. Let's look at external name. So external name, by the way, is a way of defining a service. So when you go and define a service, let's see if we can find some more here. Where's the official documentation for the external name type? There we go. So when you define a service, you have to define the type of service, right? And we're going to get into this, by the way. So this is a little bit of a jump ahead for, everybody else, myself included, is that when you want to expose a service outside the cluster, you have to define what type of exposure you want. Do you want it to be available to everybody outside the cluster? Is it something that's just going to be exposed internally? Are we exposing a resource inside the cluster, or are we exposing to a resource outside the cluster? External name is basically saying, I'm going to create an internal DNS name inside the cluster that's going to map to an external service. That external service could be RDS, because RDS produces its own DNS names. It could be another API server. And so what this does is that this basically allows you to put in a string or a DNS name comprised of digits, right? So, for example, when you look up a particular host, the cluster is going to return a CNAME record, and it might be, for example, a database name. And so accessing my service works in the same way as accessing any other services, like in this example. But when you access, it's going to return a DNS name that basically sends you somewhere else, right? So just know that in this particular case, you would set up an external name on this cluster, and you would set up a service, right? That's how you would basically get to that. Hold on one second. So let's say we set up a service right here. And what would happen is that we could then basically have our database over here in the corner. And then what would happen again is that once the external name was set up, the pods would connect to that external name. It would return a DNS resolution, and then it would basically redirect them over here. So they get redirected through the service.
I see. So external name here would kind of refer to it might use like a connect string of the RDS in the RDS example.
Yes, exactly. Yeah,
The URL of the database in the cloud.
Yeah, so RDS does publish DNS names for the hosts. Yeah. So it just give you the DNS name for RDS.
Okay.
Yeah. It's actually remarkable. It's complex and under what's happening underneath, but it's a remarkably simple concept. I'm not even sure what made them think to do this, actually, but I guess what they realized is that they probably needed to make external resources available internal to the cluster as easily as possible. So it's a good way to solve it.
Yeah, thank you, sir.
Yeah. Do note, by the way, for all of you, is that you could actually put the DNS name inside the app config for the container itself, but that just means you now have, 3 to 50 other places you're going to manage that app config. And what if it gets corrupted or wrong? This gives you a central point. If you use a service, you can just point everything there and just have it redirected. That way you have to manage 50 different configuration files inside these pods, right?
So, sir, I'm glad that you said that, because we built an application where it was an Angular-based application, and we were using the RDS. And what we were doing, we had a backend like RESTful web service, and from the RESTful web service was essentially we were directly using the the RDS credentials like a URL and username password. So we were kind of hard coding into the RESTful web service to talk to the database. So we had two parts. One was the Angular part, and another was the web service part. And web service part was, directly talking to the RDS to store the data.
Right.
But in this case, sir, what you're saying is probably instead of directly talking to, connecting to database from RESTful, what you call RESTful pod, we should use this external name to connect to the database. Is that right?
Yeah, in other words, route through the little service object that Kubernetes creates to get to RDS.
Yeah.
And there's nothing wrong, by the way, with going direct to RDS. There's no issue with that, but you can control it in one place if you do it that way. Now, I mentioned that You can do it through service names. You could also create a config map and or a secret that every single pod could read to actually get that name, and you can actually change the secret and it will change it for the entire set of pods. So just know that there's a couple of different ways to solve that. Kubernetes has the ability to inject secrets into a pod or container so that the container can actually see a username and password, and it's never hard coded into the application. It just picks it up from the environment. Yeah, so we'll talk about, that's part of persistent storage, because oddly enough, even though config maps and secrets are not like storage mechanisms, they are mounted inside of the system. So they're part of a storage possibility. Hard to go ahead.
Does the secrets config work like environment variables?
Now you can set them up as environment variables if you want to. In other words, you can have them mounted, or you can have them defined as environment variables in your container specification, in your pod specification.
Okay, is there any difference between that?
Yeah, so on the one actually makes it a file that the application needs to read. The other one is something it needs to look for in the environment, right? So there is a distinction. In one, it might be reading what it thinks is a config file, even though it's a config map or a secret, and so it's reading that file in. And the other one is just looking for it as an environment variable. So that's the distinction, is where does the application going to expect to find it?
Okay, got it. But I'm assuming using secrets would be better than injecting environment variables.
Either way, they only are readable by the application inside the actual container / pod. So either way, if someone cracks into the space, they can either read it from the environment or they can read it off the file. So it's not like one security wise is better than the other, if that makes any sense.
Yeah, that makes sense. I guess functionality, they're both similar, just different ways.
Yeah, I tend to go for files over environment variables. But honestly, they're both readable. They're both troubleshootable. I know that sounds like a weird statement. So I don't really, for me, it just depends. It's like a personal preference. What is the team been doing? If they've been using environment variables, and I'll just say, just use environment variables. If they've been reading in files, which most of them have not, just so you know, right? Then I'll just say, just read in a file. Here's another file to read in, right? To get the username and password for a database.
Okay, then.
Yeah. I mean, no reason not to let the teams decide, right? So. Okay. So that was all just a little primer on how at a very high level, how a Kubernetes cluster works. One thing to note is that it shows Docker here, which is kind of an interesting kind of setup here. The way this works is that Kubernetes is basically like OCI, what they call the Open Container Initiative. It's OCI compliant. So it's not so much that it's running Docker. What's happening is it's either running Containerd or something called CREO, which are container supervisors. And those container supervisors are talking to a standard, what they call an OCI compliant container runtime. So as long as the container is packaged with a standard, what they call a container runtime interface that's like standard, that adheres to standards, which by the way was published by Docker and CoreOS, so it's not like this is a mystery, then it actually is runnable by Kubernetes. Kubernetes used to have a shim that was required to run Docker containers because they had to do some shifting and whatnot. But Docker changed the way they do things to use what's called a runc library. And so it's a little bit of a misnomer here, because Docker is not necessarily in play. It's not like it's downloading the Docker runtime. It's not doing that, because Docker itself doesn't do that anymore. So a little bit of a different thing is that now what's happening is that we're just running container runtime compliant items, right? So Docker is listed here because you can run Docker containers, you could run Podman, you could run Builder, you could run Rocket, you could run Moby. Moby is just open source Docker. But my point being is that Docker is the most well-known containerized format that is OCI compliant. There are tons of other container formats that are also OCI compliant, and that's the main thing you need to know. For our purposes, I got to tell you, I feel like 99.9% of the world uses Docker to build containers. So just know And the reason I even mention this is that as you, over the years, what you're going to see is you're going to see container runtimes come out that are not Docker, that are specialized for certain use cases, like more security or better at networking, or, you know, better for databases versus stateless applications. So you're going to start seeing some differentiation over the next few years, because if there's one thing that we're really good at as human beings, it's making things complex. So you're going to see more of that. So those are the general notes. Okay, so here's a few questions for you, just to check, just to make sure that we were all paying attention. So if I said that one of these is the data plane and one of these is the control plane, which arrow is it, the orange or the pink arrow? That's the data plane. Which one of these is the data plane for
Orange.
Kubernetes? Orange. Good. All right, well then by default, obviously that makes the pink one the master, right? Now, earlier I said that all of this communication, other than the application communication, like the service traffic and whatnot, Kubernetes talks to every other component in Kubernetes using a standard kind of thing that we
API.
also, APIs, good, good. Okay, so we're using APIs to talk to everything, right? Now, I made a very compelling statement that at present, the open source community has no desire to convert the masters / leaders over into this operating system. What was this operating system?
Linux.
So they run on Linux, but they don't have fun to go to Microsoft, like Windows.
They're not going to Windows. That's exactly right, Vinod. So everything runs on Linux. The worker nodes can run on Linux and Windows, but they have no plans to convert the master systems over to Windows. They're just going to keep them on Linux for the time being. Okay. And then what is the acronym for the organization that manages and publishes everything open source around Kubernetes?
OCI.
No, that's the Open Container Initiative. So that's standard for Docker and CoreOS. That just governs containers. Who governs Kubernetes?
CNCF.
CNCF, that's right. The Cloud Native Computing Foundation. So good to stay connected with them. All right, what is the basic unit of deployment inside Kubernetes?
Pod.
Pod, that's right. In every single pod, I said there is ideally only one what?
Primary application container.
Good, that's well said, actually. That's better. I think that's better than how I said it. Primary application container, that's exactly right. I said that if you are brand new to Kubernetes, like you're a brand new operations team and you're running Kubernetes for your first like month, 6 months, first year, I said it'd be a great idea to not put these types of applications inside your cluster. What was that not?
Databases.
That's right, Hardik. It's a really good idea if you are operationalizing a cluster for your first year at least. Do not run any data stores of any type inside your Kubernetes cluster. I know that sounds arbitrary. You can go quicker if you want, but it's usually recommended like 6 months to a year. Don't run any production databases inside of your cluster. You want to mess with non-production? Great. Otherwise, just externalize it. By the way, I kind of implied this earlier. So true or false, Kubernetes is aware when it's on a cloud provider.
It can be on any cloud, right?
Well, let me state the question again. Is Kubernetes aware that it's on a cloud provider when you install it onto a cloud provider? Is that true or false?
False.
So oddly enough, Kubernetes is cloud aware, right? So when you put it on a cloud, it actually starts a dedicated piece of software called a cloud controller, and it will actually manage your AWS resources that are relevant for Kubernetes for you. You can extend that, by the way, so that Kubernetes can actually kick up any AWS service that you want. I don't recommend doing that last one, but just so you know, Vinod and I were talking earlier when he asked about, I want to talk about ingresses. When you start an ingress and Kubernetes, it has permissions to interface with AWS because you gave it permissions, it will start an application load balancer on your behalf, configure the whole thing, configure DNS, and set it up so that the application load balancer, which sits outside the cluster, will route traffic to pods inside the cluster. So Kubernetes is actually cloud aware when you give it the right credentialing, right? It does have to have permissions, by the way. You can't just do things out of the box. Okay, last question. What's the maximum number of worker nodes you can have in a single Kubernetes cluster, a standard one?
I think 5,000.
5,000, that's right. Note that those limits do not apply to any managed Kubernetes system. So do not expect to run 5,000 worker nodes in EKS, which is the Elastic Kubernetes System in AWS, or AKS on Azure, or GKE. Although I think GKE is pretty good, close to the max. So just be aware. That 5,000 number is like 1.2.1 of standard Kubernetes on a standard like EC2 or virtual machines or whatever. Oh, actually, there was one more question. True or false? Kubernetes requires an operating system in order to run.
It requires a runtime. Yeah, I think so, right? It runs on Linux.
Yeah, so be aware. Kubernetes has to run on top of an operating system. It in and of itself is not an operating system. So it requires either Linux or Windows as on the worker nodes to function. So most people don't realize that when you run containers, you still actually have to have virtual machines. Now, I know there's managed services out there that allow you to abstract away the virtual machines. Someone's running the virtual machines. It may not be you. It might be AWS or Azure or whoever, but just know that it still requires an operating system to function. Not much of one, but still requires an OS. Okay, questions before we move on?
So, sir,
And
when it runs on the, like, let's say virtual machine, like for example, in the cloud, we run it on EC2 machines. So then, in a way, it's the work is running on a virtualized operating system environment, right?
Right.
Gotcha.
So it doesn't matter if the OS is virtualized or actually on physical hardware. Kubernetes doesn't really care.
Gotcha.
Yeah.
And the last questions that I had was for that 5,000, worker node configuration. How many master nodes you think they may be using?
So this was a shocking thing. We only needed 5.
Wow.
We didn't need 7. We didn't need 9 or 11, 13. We didn't need a lot. We had 5, and they weren't like super big boxes either. They were oh man, they had 64 gigs of RAM, and I think they had a 16 processors, so it wasn't even like a high ratio either. So that was it. And they had plenty of storage space for etcd because there were so many boxes and things to manage, but that was it. So 5, right? It was not that many.
Yeah, I have a quick question. So you are saying master, right? I have come across like HCD control plane. So all of these are considered master. Like, is it HCD is one master, one kind of master, and control plane is one kind of master?
The control plane includes all of the components needed to manage Kubernetes. That includes etcd, API server, some other stuff that we're about to talk about. But so those are subcomponents that fit inside the master systems. Yeah,
because when I deploy a Rancher cluster, it comes with some HCD, some control plane, some worker nodes, and some combination also, like HCD worker or HCD control plane. So all kind of combinations we have deployed.
Yeah, so all the components, right, that make up, because Rancher does the same thing, right? Rancher, since Rancher is a meta manager for Kubernetes clusters for the most part, what it does is it usually either sits on top of the already existing resources that Kubernetes is using, because typically you deploy Rancher into a Kubernetes cluster. So what it does is it adds its kind of meta components on top of what's already there. If you deploy Rancher independently, which you can do actually, it does require its own etcd database, but it follows the same kind of component structure as Kubernetes. It has its own API server. It usually has some kind of authentication like mechanism. It's got a bunch of other components to it. Some of them deviate from Kubernetes, but a lot of them just mimic Kubernetes. So a lot of what you're about to see as far as what's the internals of Kubernetes are, Rancher follows like 80% of it. There's just a few extra things that Rancher has that, and of course the code's different. So don't let me mix and match there. right? The code's different, right? But Rancher operates very similarly on top of Kubernetes. Okay. Good questions.
I have one more question.
Yeah, go ahead.
For the 5,000 max worker node limit, is there any limit for the cloud managed solutions?
Oh, yeah. So there used to be a company that actually, it just got bought by IBM, and hold on, StackRox. Yeah, StackRox, Kubernetes. Comparison. So sorry, just bear with me just 1 second. StackRox was the name of the company. Oh, you're not doing, wait, why are you doing that? Hold on. StackRox. There was a document that they published, and there it is. Good. I think they have an updated version of this. But this document that they published would show things, for example, like what versions were available. Now, this is now almost a year old, so let's be clear about this, right? So like we're up to 1.21, 1.22 is kind of mainstream, but this would show, for example, all the limits of, like, you know, the control plane, what's the maximum number of nodes. So they had a document in here that they published, and I know they've updated. So see how it says 5,000 is the max nodes per cluster right here. Notice that GKE supported 5,000, but like the limits on these other systems were actually a lot more complicated math. So I'll post this into chat. This is 2021. I don't think these limits have changed as far as the maximum number of nodes. Also remember that these nodes could be massive, right? These could be 24 terabyte machines. I know that sounds weird. These could be 24 terabyte machines with 448 processors. So just be aware, though, that supersizing your machines in Kubernetes has some restrictions, because Kubernetes can typically only handle somewhere between 100 and sometimes 200, but typically it's 100 pods per system. So if you didn't hear me say that, let me say it again. You can only really put about 100 applications, maybe 110, maybe 120. If you're using OpenShift, you can get to 200. But you can only really put 100 applications, 100 pods onto a single box. That's not a resource limitation. That's like a network management and other kind of limitation going on with Kubernetes. It's hard to manage 100 virtual network connections on a single box. It's just like exhaustive and conflicting, and you run out of IP addresses, and there's a bunch of like challenges and issues there. So know that while you can get to 5,000, you know, running a massive set of servers to get more horsepower isn't necessarily going to translate, just because you can only get 100 applications per host usually. Does that make sense? Was that hard to think? Was that you asking that?
Yeah, it was good. So you can only usually get maybe about 100 pods instead of, how would you get to 5,000? Or you'd need like more boxes?
You need more boxes. Yeah.
Okay.
So notice here on this same paper, see how it says 100 is the Kubernetes max. Notice it says it's configurable. Notice that GKE will do 110 pods per node. I shocked. I didn't know this. Azure will do 250, but usually if you use the Kube network, it's 110. The AWS is interesting because you got to do a little bit of math, because it depends on the number of ENIs that you have, the elastic network interfaces that you have inside the system. So yeah, so some math there, but typically you're going to cap out about 110 applications per host. So if you add a massive box, but you can only fit 100 applications, then you might be over provisioning your boxes. So that's why I mentioned that.
So sir, when you say 100 pods, are you referring to 100 instances of one application pod, or 100 individual, separate, how to say?
Doesn't matter. It could be 100 separate. Yeah, they're
see.
distinct anyway, whether they're copies of the same application or whether it's 100 different applications, it's still a pod. So it doesn't it doesn't really matter whether it's a
So,
replica or.
Sir, I remember like, we did some proof of concept for our government work, and we wanted to show them like, like how easy it is to scale out,
Right.
applications on Kubernetes. And I remember we used a J meter to prove that. And to your point, to be honest with you, I'm not sure if we went beyond 100 parts, but we kind of let them to believe that it could be hundreds and thousands, depending on the workload. And we had this threshold, if the CPU utilization or queue size, in the J meter, to basically spin up more pods. So you're saying that if it goes beyond 100, then that there could be issues?
Yeah, I'm saying that you need to check basically on a bunch of different things, including, soft file limits, hard file limits. There's a bunch of things that are happening underneath the covers.
Or
So
we
if you,
have more worker nodes, right, sir?
you just add more worker nodes, right?
Oh,
In or-
gotcha.
Yeah. So in order for us to get to I think it was like 49,700 like pods for the NFL's like proof of concept.
Yeah.
I mean, you better believe that if we stopped at 100 pods per system, right? So that's what the cap was. And that's a limit that's in Kubernetes, by the way. It's not going to let you deploy more than 100. You have to go in and change and configure that. And so at that point in time, as you can imagine, if we were capped at 100 and we wanted to get 49,000, right? We ended up with about 400 and change worth of boxes in order to pull that off, right? So, that's the thing you're looking at, is that you can always add more nodes to the cluster, even if you run into the 100 pod cap. But I just want to say this is that typically people run out of resources well before they hit the 100 pod cap. If you run, let's say 50 pods and each of them is taking 2 gigs of memory, pretty good average actually, you're going to be eating 100 gigs of memory. So, it just depends on the size of your worker nodes. But I mean, if 5,000 was the limit and you could run 100 per, that means you could get to a 500,000 pod setup if you needed to.
Mm-hmm.
Right? So. All right, so I posted that link in there from StackRox. I think there's an updated version of this actually. I want to say they published one that was newer, but yeah, I would have to parse through that, and I don't want to take the time to do that right now. So just know that StackRox, which was bought by Red Hat in IBM, I want to say they published one in May actually. That was actually more up to date, but they were publishing this whole EKS, GKE versus AKS kind of analysis. So yeah. So if you want to see the comparisons on the providers, note that if you always want the latest, just go look at the providers documentation and it'll tell you what their maxes are. Everything they pulled for this report is actually in the documentation from Azure and AWS, et cetera. Okay, let's go through a couple of concepts because we've actually talked about quite a few here already. So first is that, a cluster is nothing more than a collection of virtual machines, basically, that are focused on a common purpose. And, it could be physical machines, it could be virtual machines, but basically it's like, if you have a database cluster, that cluster is focused on running databases. If you have a Kubernetes cluster, that cluster is simply focused on running containers. That's it. It's focused on running Kubernetes explicitly for that purpose. Now, what's interesting is that, let's say you have a cluster and it's comprised of a bunch of different boxes. And you decide that you want to put some kind of security cordon around the boxes, because you're like, hey, you know what? I really want project A to have its own kind of like private space, and I don't want them to mess with project B. So here's something cool that you can do with Kubernetes. And by the way, Rancher enhances this by adding another concept called projects. But what happens is that you can actually create what's called a namespace that runs across all of the nodes, including the master nodes, but particularly the worker nodes. You can create these things called namespaces, and the namespaces act as security levels or isolation boundaries for pods that you're running. So in this, why did I choose orange? That was weird. Let's choose green instead. So for example, let's say I create a namespace, and the namespace is like an isolation boundary. And what can happen is that in this case, let's say that, like, this is hold on. This is team A, right? And then down here, I've got team B. And down here, I've got team C for green, right? Or C. And what's happened here is that I am deploying their applications in their respective namespaces. Now, this is going to cut across all of the nodes in the cluster. So when you create a namespace, like let's say I create a namespace called A, that namespace is going to exist for every single box in the cluster. And so what will happen is that as I deploy an application, let's say, let me actually switch this. As I deploy an application up here, and it's going to go across the entire cluster, the only people who are going to have access to it are people who have been granted permissions to that namespace. If I come down here and deploy a blue application, and I'm going to deploy it, let's say on these nodes for the B team, the only people who can see the blue pods in the pink namespace are people who have access to the pink namespace. And it just continues down the road, right? So for example, if I deploy the white application down here in the green namespace for C, the only people who can actually access that are either cluster administrators who have access to everything, or people who have been granted specific access to that particular namespace. So like I could create a security namespace, a logging namespace, a project A, project B, project C namespace. I could create a system namespace, which by the way, is what Kubernetes does. So Kubernetes actually by default creates a couple of namespaces for you. Let's go take a look at that. Sans my drawing. Can you see my Git Bash terminal right now?
Yes.
You can, or you could until I put it back. Let's see. By the way, so I run Minikube on my Windows box. I also have it in a virtual machine and also in Ubuntu. Do you know, by the way, that if you run it on Windows, sometimes the redirection syntax, like if you try to run a command or whatever inside a container, doesn't work. And that's a Git Bash limitation. It's not a problem with Windows. So let's say you're using kubectl and you want to get all the namespaces, right, on a system. Wow, that's taking a long time. Usually it comes back quicker than that. What's happening? Hold on. What you doing? Pardon me 1 second. My demo is failing horribly because something's hung. All right. Weird. Okay. Anyway, I don't want to spend a lot of time on that, but something seems to be messed up here. Let's try this one instead. Oh, man. Okay. I didn't start it yet. That was my fault. Okay. I might have to show you that later, unfortunately, because I thought I was prepared and apparently I'm not. But what this is just allows you to create an isolation boundary across an entire cluster. Just know that you cannot limit namespaces to like certain nodes in the cluster. So when you create a namespace, though, it just creates a security partition or a cordon inside of the entire cluster. You can create as many namespaces as you need. There is a max, obviously. I don't know what it is off the top of my head. I want to say it's like 1,000. But just know that you can create these segmentations if you want to isolate your teams from each other, to isolate people from accessing like monitoring or logging or whatnot. So namespaces, by the way, pods can live in a namespace. Nodes have to live in a namespace. So pods can exist in a namespace. And by the way, they always exist in at least one namespace. Nodes exist in all of the namespaces simultaneously. So remember, a namespace is just a slice of an entire virtual cluster. So talking about nodes, so they used to be called minions, by the way. You might see that sometimes in the documentation. They're sometimes called worker nodes. Minions, nodes, worker nodes, all the same thing. Doesn't matter, right? What we're talking about is we're talking about either physical or virtual machines that are part of the cluster that are hosting pods, which means they're hosting containers. This is where all the work is done, right? And you may know this, by the way, but Windows containers have to run on Windows. Linux containers have to run on Linux. The reason for this is that containerization is just process virtualization. You're not actually running a kernel. You're not running an operating system. I know it looks like you are, but you're not. You're simply running the binaries for the kernel inside the system. Now, the master we already talked about, it consists of a bunch of different components, which we're going to get into, but just know the master is responsible for all cluster level scheduling of pods, the handling of recovery, readiness, the whole 9 yards. So just know at a minimum in production, you're typically going to run 3 master nodes, also known as leaders. Pod is the basic unit of work and deployment inside Kubernetes. We already talked about this. It's usually, the way in which you actually kind of like schedule and set up an environment. Each pod will typically get a unique ID. Sometimes the IDs are not this crazy alphanumeric. Sometimes they just increment by 1, or sometimes they don't change at all. So it says that each pod gets a unique ID. Just know that there are pods that actually keep their names. They're called stateful sets. So we'll if we can, we'll take a look at that. In most environments, all the containers that are inside of a pod all share the same IP stack. They all share the same network stack, but every pod will get its own internal IP address usually. Something to remember, especially in a cloud environment where you have a limited number of IP addresses because maybe you chose a small range or whatever, is remember every single pod you start is actually going to take an IP address. So going back to my little NFL foray, when we were running 49,000 and change pods, every single one of those pods had an IP address. So you better believe that we were running on a large network because every single host had an IP address. Every single pod had an IP address. Every single service had an IP address. So we were running on a very large 10 network to execute that. So now I think we talked about this already, but when you group containers into pods, the question you have to ask is, do I want this to scale together? So just remember that. If you don't want your database, you don't want a 1-to-1 ratio of scale, then you don't want to stick it inside the same pod. If you do, great, no problem. Other things to think about is that just like with cloud resources where tagging is king, with Kubernetes will often automatically label stuff for you, right? But you might want to go in and label your worker nodes. It's like, hey, these are Windows nodes and these are Linux nodes. Now Kubernetes will do that for you, but you might want to create your own manual label. Or you might say these are machine learning nodes because I want to run my GPU containers on them. Or you might have non-GPU nodes because you don't want to run machine learning workloads on them. You might have nodes that are labeled stateful and you run databases on them. You might have nodes called stateless and you don't run databases on those, right? So it just really depends on what your strategy is for approaching your Kubernetes cluster. But labels, by the way, can be very useful for saying these are all our production. That's if you're running this all in the same cluster, by the way, but these are our production nodes. Here's our dev nodes. Here are our QA nodes. You might say, Mike, well, why would we do that? Maybe because of a licensing constraint. People do that. I'm a big fan though of cluster as a service. It just depends on what your cost restrictions are. So the way this works is these are key value labels. So you have to have a key and then a value. I think the keys are limited to 255 characters. There's some details on that. And each pod, by the way, is going to end up with labels, and they can have multiple labels that you give them. So just know that labeling can be a really important just general thought and strategy for when you manage your cluster. Label syntax, so here it is, like the actual components itself. You can have a prefix and you can have a name, and the values, by the way, follow the same restrictions as the names. So a prefix has to be a valid domain name. So it could be like beta.kubernetes.io. It could be storage.kubernetes.io. In other words, it has to be a valid, fully qualified domain name. And but it can only be about 253 characters at most. After the prefix, you could have a slash, and then you could have the name. And the name can only be 63 characters long. Now the name could be, so here's an example. So let's say that we had storage.kubernetes.io has our prefix name. And then what happens is that for our actual name, it could be GP3 disks, right? And that could be the name, or it could be, what's another one I've seen before? Oh, standard storage. Hold on, let me pull this out a little bit. And then what will happen is that that's the prefix before the slash, after the slash is the name. And then what that will be set to is it'll be set to like GP3, for example, which is AWS's kind of SSD, standard SSD, right? So you can see stuff like that. And then you might have another label down here that says storage.kubernetes.io / fast storage. And we've done this a lot actually, where it would be IO2. IO2 is the provisioned IOPS storage inside of AWS. So this, by the way, you might say, look, I only want these pods to run where fast storage is available. Now with AWS, it's available everywhere, but you might have restrictions like that where you only want these boxes to have provisioned IOPS and these boxes to have GP3, because maybe these boxes are all like EBS optimized or optimized for storage. So you can actually use labels to control things. Another example might be that you might have your own kind of customized domain name where you're like, this is K8s.bah.com. And so that could be your prefix. And then you could say GPU present equals false, right? K8s.bah.com. GPU present equals true, right? And so you could schedule pods. It says, look, these are machine learning pods. If GPU present equals true, I want you to schedule onto these worker nodes. If GPU present equals false, do not put those machine learning applications there, right? So you can use labels as a way of controlling the scheduling of your pods. That's what we mainly use it for, right? You can also use it as identifiers, like you could put billing codes in here, like you could have, for example, K8s.bah.com, and it's like billing code equal to, whatever the number is.
So, sir, sometimes in the, like deployment manifest or, any service manifest, we notice like, not service, but maybe deployment or pod, we notice like a simple labels, like a name equal something. Meaning that we don't necessarily use any domain name there.
Oh yeah, you don't have to use the prefixes if you don't want to. They're optional.
Oh, okay, gotcha.
Yeah, prefixes are optional, right? You don't have to do that, right? It could be bill code equals, right? You don't have to put prefixes on there.
Gotcha, thank you.
Yeah. And when Kubernetes says it though, it'll all, I don't think I've seen it yet not put a prefix on there to make sure that that they created it. Yeah. So yeah, you don't have to do that at all. Okay. Now labels have our restriction, like labels are labels, right? So they are ways of tagging your environment. And they're actually used by Kubernetes and can be used like in pod specifications and other controllers to control scheduling or whatnot. Annotations are interesting because they say that it's just arbitrary metadata, but I actually have seen people use this to control Kubernetes. But for the most part, Annotations are just notes that are made about your infrastructure. That's all it is. So unlike labels, there's no restriction. You can dump a lot of data and character types inside the annotations because Kubernetes doesn't use them to manage the cluster. So just know that labels have some restrictions to them. They can be used to manage Kubernetes. Annotations don't. So annotations are just there for you to put notes and metadata and other stuff inside your Kubernetes installation. That's all it is. So think of annotation as like a note. I'm annotating, you know, we used the Helm chart 5.5.6 here. We had a problem with it. And so we rolled back to 4.9.3. So just be aware that if you roll this up, it's going to have issues. You know, like you can put like all kinds of stuff in there. It's not really meant for like, you know, like a paragraph, but you can put a lot of stuff inside of an annotation. The label selector, by the way, allows you to, and you can run this on the command line or actually in the pod specification. And don't worry, we're gonna do some of this. This allows you to basically say, look, I want to deploy these pods like before, where GPU equals, you know, GPU present equals true, right? So we can say where role equals web server, as you can see here, or you know, where application doesn't equal sales, does not equal sales. That's what the little exclamation point is, right? You can actually use create a set, like, you know, I want to, where the role is one of these, then we can do it, right? So you can actually go through a list or an array of labels if you need to. So there's a bunch of selectors that you can use. It's just up to kind of what you're trying to accomplish. You need to look at the documentation if you want something more sophisticated. Now, one thing to note is that let's say someone comes to you and says, you know what, I need to run oh, you know what? You know what the funny thing is about running white as a color? It doesn't show up, right? So let's say someone comes to you and says, you know, what I want to do is I want you to run, you know, 2 instances of my pod. And then they come back to you and they say, you know what, I want you to add a third. What they've done is they've changed the replica count inside your deployment type, your workload type. So it could be a deployment, could be a stateful set. There's different like workload types inside Kubernetes, but replicas is a concept that's common to all of them. And what happens, and you can ignore replication controller because it's pretty much retired, right? Replica sets, that's the thing that like creates the copies of your application. So if 3 of these were 3 of the same Nginx server configured the same way, and you just wanted 3 copies of them, you would change your replica number to 3, and the replica set would increase the number of running pods to 3. If I turn this up to 6, and I only had 3 nodes as an example, it would actually then take that and it would actually run. Wait, was that purple? No, it wasn't purple. It was pink. Hold on. It would then actually run, if I turned it up to 6, it would run 6. So 3 more pods would get added. This like concept, this device, the replica set, is what turns your replicas up and down. So when you say I want 3, it gives you 3. You want 50, it's going to give you 50 copies of the same container image inside that pod, and it's going to run those pods across the entire cluster. So be aware that a replica set, it's going to go right to the number you tell it. So if you want 5 and you kill 1, it's going to add 1. If you want 5 and you add a 6th, it's going to kill the 6th one and keep it down to 5. So whatever the number is, as you tell it that you want it to run, the replica set's going to control that and make sure that that's the number that's always present.
When you set a replica count, does it control the number of containers on a single pod, or it's all the pods?
No, just in that pod type. Like if it was an application, like for a project, what happens is you create a deployment type, and so the replica set controls the number of pods in that application, not the containers. Containers don't change.
You were mentioning number of containers. It will control the number of application copies, right, inside the pod.
It controls the pods. It won't control what's in the containers. In other words, since the pod is the basic unit of deployment and pod contains containers, it doesn't change like the containers that are in a pod. It only adds more pods or removes pods. That's how it controls the deployments, is it just adds pods or removes pods. Doesn't change the configuration of the containers inside the pods themselves. Because remember, the pod is the basic unit of deployment. Good. Let's see. So I wanted to do this is that I know we're about halfway through this first section. And then actually what we're going to do is we're going to do a quick lab. Here's what I'd like to do is I want to just take a quick break. It's like 11:33 right now. We've been going for, I know, for just an hour and a half, but that was kind of a known thing. So it's 11:33. So let's take a 15-minute break, but let's assume that it's 11:35. So come back at 11:50. I'll put up a little timer. So come back in about 16 minutes. Okay. All right. 16 minutes. All right. So we were talking about replica sets, which is basically a way of controlling the number of pods with a single application, right? So if Project A has a brand new kind of like RESTful API they're publishing, how do you add multiple instances of that RESTful API? Well, you actually set it in the pod specification where you set the number for the pod, and the replica set enforces that number, right? That's its job. Oh, you know what? Actually, I was going to check on one thing. Let me just make sure. There we go. Good. Wanted to restart my Minikube setup just to make sure I could get to it. And then services we talked about before. Services, think of services as virtual load balancers. That's not what they really are, but they're basically abstraction points that you can create where you can route traffic to them and they send the traffic out to like backend pods as an example, or to an external service, or well, really honestly, those are the only two options. It's either going to go to a pod or a bunch of pods, or it's going to go to an external service. So I like to think of services as basically almost like little virtual like load balancers. They're just they will redirect you to whatever pods are available, you know, for whatever connection you're looking for. They're not going to go to all pods simultaneously. It's going to go to one pod, usually in a round robin fashion, right? So what this allows you to do is this allows you to create a virtual endpoint that you can then hit to get to whatever you need on the back end. Sometimes services are internal to a cluster, meaning they can only be seen inside the cluster. Some services like load balancer types or node port types can be seen outside the cluster. So, which means that like you could hit web services on the, you know, on the internal side. Services are, you know, can be load balanced by Kubernetes, which is why I kind of like to think of them as load balancers. They're just tiny little virtual load balancers. Every single node in the cluster is aware of services that are available, right? So just remember that if you hit a node on a certain port and your service is a node port type, it doesn't matter whether the pod lives on that node or not. Every node in the cluster is going to know where to go to find out where that pod is. So it redirects traffic. So some of these services are typically cluster wide, meaning that even if there's a node involved that does not actually host the pod in question, it is aware of where to send traffic to get to that pod. This is a much longer conversation, which we'll get to actually when we get to deployment and some of the services setup and exposing applications. But right now, I want you to conceptually just think of services as load balancers. Now, a volume, also known as the storage volume, basically is, you know, a volume is how you attach permanent storage to a pod and specifically a container inside of a pod, right? So like if you have a database application that you're running, let's say it's Elasticsearch, and you want to persist that data if the pod restarts, then you have to use a volume. If you do not attach a persistent volume to a pod, when that pod restarts, all the data for those containers is lost. This doesn't work any different than Docker. Docker has the concept of volumes as well. If you don't attach a volume to it, it's not going to work. It's not going to persist, right? Secrets, we talked a little bit about these before. These are literally just like sensitive information that you want to share just with the application inside of a pod. In particular, like a container inside of a pod. They're mounted as files. You can also basically make them available as environment variables through those, mounting in files, right? And that same secret, by the way, could be available in multiple pods. You get 1,000 pods, you could have the same secret, like database username and password, available to them through that secret. Be aware that by default, secrets will be stored as plain text inside of the etcd backend data store. You can enhance that / shift that if you really want to. In other words, you can do it encrypted. When I say it's served as plain text, by the way, it is base64 encoded. So it's not like someone can just look at it and grab it. You know what I mean? It is plain text, but it is encoded. It's not encrypted. Resource quota is a concept. Oops, sorry,
I had a
something, my question. Yeah, go ahead.
Question on secret. So that base 64 encoding, is that when we create, does the Kubernetes, or for example, kubectl commands can convert that into base 64, or we need to do that ahead of time?
Oh, no. It's converted. It's base 64 encoded for you.
Oh, gotcha.
But it's not encrypted. You know what I mean? There's no secret key algorithm. You can just unencode it if you want to. But my point in saying that is someone can't just glance at it and instantly know your password, for example. So, yeah. I mean, because they make it sound like they're storing, like if my password was, I love cats, they make it sound like I love cats is what would be available for you to see. And you do have to decode it. So if someone's looking over your shoulder, they're not going to see all the sensitive information. So not that base 64 encoding and decoding is hard, but still. All right, other things to note is that you can actually set resource quotas on basically a pod level. You could also do it on a namespace level as well, and you can do it cluster wide if you want to. Rancher, by the way, adds this concept of projects around namespaces. If I remember correctly, you can actually set resource quotas on a project level, meaning like if you wanted to like have a team and then it had a bunch of namespaces underneath it. The bottom line is that you can set resource quotas on a bunch of different levels. That's really the thing you should take away from that. You can set it at the pod, the namespace, and the cluster level. Now, this could be things like, for example, what percentage what kind of CPU do you want, and what's your max? So just know you can do like requested, and you can do hard limits as well, and say, look, this pod cannot consume more than 4 gigs of memory and what they call like 1,000 milli CPU, which is basically just 1 CPU because it's milli CPU, right? So there are other ways to add other limits. So you can extend Kubernetes to add other limits if you want to, but those are the main ones. General recommendation is do not ever launch a pod in production that does not have some kind of resource limit on it, unless it's on its own isolated box. So I will typically, when I run a cluster, have a box that's labeled the bad actor box. And if I have a pod that for whatever reason doesn't behave very well, or I'm doing performance testing on it, I will put in the label selector to go to the bad actor box. And then what will happen is I'll watch how the box performs with no limits on it. And if I see that the application grows to like 16 gigs or something like that, I'll just note its performance profile. Because sometimes what things do in production is not what they do in pre-production. So if I still need to run a production workload, but I need to take the limiters off and see how big the container will grow, I'll stick it on what I call a bad actor box. And that's simply a box in the cluster that has a label where it says bad actor equals true. And I'll put that in the pod specification so that when the scheduler sees that, it will automatically push it to that box. No other nodes, by the way, sorry, no other pods will be allowed to run on that box because I'll taint it. And I'll talk about taints and tolerations, but I'll taint the box. So if you don't have the toleration for the taint, you can't actually run the pod on there. So, you know, something you can use to kind of like also control your environment is to have a bad actor node in the corner over there. But you can set resource quotas. And again, do not launch into production without having some kind of resource quota limits unless you just are okay with things running away. Because if you get one memory leak, it's going to eat all the memory on the box if it can, right? Authentication and authorization in Kubernetes. And this is all just a high level setup, by the way. We're just setting you up for what we're about to deeper dive into later on over the next 2 or 3 days. Sorry,
Hey, Michael, I had a quick question.
Yeah.
Sir, the that bad actor node that you talked, bad actor part that you mentioned, that approach, could that approach be used to kind of get an idea of what resources you should be, you know, your application parts need?
That's what I do with it actually. So I'll create a cluster. Let's say there's 10 nodes. I'll create an 11th. The box will be over there. And the application team comes to me and says, we don't know how many resources this needs, but they still want to launch it. And they want to put it in production. So what I'll do, and sometimes I'll spin up a box for this, just to be honest, but not if it's on AWS, I'll just spin up another dedicated node, right? And what I'll do is then I'll taint the box so nobody else will schedule on it. And then I'll set up the pod selector to only run on that node. And that will be the only pod on that box. And then what I'll do is I'll performance profile snapshot that, like, how's it going to run? So for example, the app dev team may come back to me and say, hey, it's going to take 10 gigs of RAM to run this pod for every 5,000 connections. And we're expecting 10,000 connections as an example, right? What will happen is that I'll see that at 5,000 connections, it's eating 20 gigs of RAM. And so then that allows me to go back to them and say, hey, you know, this is what you're going to end up paying for internally, because it's all funny money, right? You need a 20 gig container to handle this thing at 5,000 connections. And what I'm going to do is I'm just going to, at every 5,000 connections, I'm going to give you another container. It's going to eat 20 gigs of resident memory. So it's a great way to actually performance profile in production, because they'll think that in non-prod, they'll say, look, we saw, you know, 10 gigs at 5,000 connections, but no one really knows how users use the production applications in many cases. So like once it launches, it might use a whole lot more memory, or it might use a whole lot less. It just depends. So, yeah.
Thanks.
Yeah. But you will have to taint the box. Otherwise, the minute you bring it up inside the cluster, Kubernetes is going to rebalance, and it doesn't do this every time, but it'll start sending pods over to the cluster. So if you taint it and say, look, if this box is only reserved for certain usage, then Kubernetes won't automatically send pods over there. So just remember, you do need to block it off to a certain degree. All right. So general statements about authentication and authorization. So here's the weird thing. Kubernetes doesn't have the concept of users, which is a weird statement because we can manage users on Kubernetes. But what Kubernetes is actually doing is it's creating a certificate, and the certificate has the username inside the subject name for the certificate. So it's actually creating an SSL certificate, right? And or is it or is it a 509? Actually, I can't remember what kind of certificate it is off the top of my head. So what happens though is that, you know, Kubernetes can actually either grant you access based on attributes, like of your username, you know, the resource that you want to access, or your username. You can do it based on roles that you create. Like, are you a cluster admin, right? Or are you just a regular user? You know, are you part of this namespace, not part of this namespace? You know, there's a couple of different ways to approach that. Kubernetes, though, is really made to actually hook into third-party authentication systems. They really kind of punted on this. So like, for example, if you start a cluster on AWS, you can hook that actually into IAM if you want to. and let IAM do authentication for you. And so Kubernetes becomes like an identity broker, if you will, for IAM. So then you can use your IAM credentials to log into your Kubernetes boxes. So role-based access control, attribute-based access control, and then kind of like webhooking, like it has to use SAML. I've never seen anybody like talk about this, but I think it uses SAML 2.0 in order to hook in. It might be using OIDC, but I'm pretty sure it's SAML. That's the webhook that allows it to hook into third-party federators. I've seen Kubernetes hooked up to Ping Federated, Okta. I even saw someone hook it into Active Directory one time. That was a little strange, but it worked. Obviously, straight up LDAP, Kerberos systems work just fine. We'll talk more about that when we get to actually the security section, but just know that it does role-based, attribute-based, and it will hook into third parties. Routing in Kubernetes. So there's two things that are harder in Kubernetes. That's networking and security. And security is just because we're lack of familiarity. Networking is because there's like multiple layers to the networking. You've got networking for the containers inside the pod. You've got networking when a pod goes to another pod on the same box. You've got networking for when a pod goes to another pod on a different box. Then you've got service to pod networking. You got all the layers of networking here. So just know that there are all kinds of virtual bridges, virtual gateways, and other things in play once Kubernetes is involved. We are not necessarily going to deep dive into the Kubernetes networking. We're going to talk about it a little bit in architecture. But when we expose applications, we're going to expose a little bit about what's going on with networking as a result. And I have a little slide deck actually from AWS about Kubernetes, about the Kubernetes networking that I'm going to talk about just a little bit. One thing we're saying is that by default, you cannot get inside a Kubernetes cluster from the outside. So Kubernetes will not let you talk to Kubernetes unless you have a certificate, which means you have a user, or a service is exposed. Otherwise, Kubernetes will not accept outside connections. So just know, while I wouldn't put a full-blown cluster on the internet without hardening it first, by default, it doesn't allow you to do anything. You can't see it, can't get inside of it. You know it's there, but you can't really do anything with it. As you may be aware, let me annotate this just a little bit. Let's say you have a cluster full of machines, right? And you go to download your brand new custom, Rust API that you wrote, right? So over here, you've got a couple of masters and you've talked to the masters and you said, you know what? I really want to take this green application right here and I want to run it on all of these systems. Like I want to deploy it on, you got a 5 replica, right? Pod, if you will. In order for that to work, what needs to happen is that there needs to be, oh, that's not what I wanted. There needs to be a third-party registry over here. So what has to happen is that now our little green application, it has to be built and pushed to a registry. So someone's got to come out here and actually take this little green application that we've got, and they've got to build it and then push it out here on the registry. And then from there, what will end up happening is that it will then get scheduled onto all of these particular boxes. So what will happen is that the kubelet on each of the nodes is going to go grab the image and then pull it back down. Grab the image, pull it back down. Grab the image, pull it back down. So you'll end up actually with 5 instances of the image running on these systems. But all of that happened because there was a registry they could talk to. Does anyone know the most famous Docker registry in the entire world?
Dr. Hub.
Right, pretty straightforward, right? Docker Hub. So Docker Hub is where by default Kubernetes will pull if you do not put a URL in front of the image name. So if you don't put a URL in front of the image name, it's going to assume you want to pull it off of Docker Hub. If you don't have access to Docker Hub, it's not going to be able to deploy. So just remember that you do actually either have to specify in the pod specification or change the way the cluster looks. But by default, it's going to go to hub.docker.com to find its container images. Now you can
So,
run
sir,
your own.
what is
Go ahead.
what is the generic name for the Docker Hub? You said it container registry or image Docker, excuse me, image registry. What is this called? What registry?
So the type of technology is just a container registry or a container
Container
repository. Yeah.
Gotcha.
Yeah. Here, obviously, they're calling it something very specific. It's the Docker registry, but this is actually a piece of software that you can download that is a container registry.
Gotcha.
Yeah, that's all it is.
It just stores the Docker images, correct?
That's it. Just container images. Yeah. This one obviously will only do Docker. Harbor, which is another CNCF project, will do a variety of images. Almost all of the like Artifactory, like JFrog's Artifactory, Nexus, and all those, there's usually a checkbox where they will imitate a Docker repository or container repository or registry. So just note that if you're already using like some kind of artifact repository, you can usually extend it to be a Docker repository as well. Okay. And that's actually our last little section, right, about Kubernetes and just a general skim of the various components. We're going to go into these components at deeper levels of detail over the next like 2 to 3 days. So don't worry if you're like, well, Michael, I think we talked about volumes, but I don't really know what they are. We'll get into it. Questions?
One more Kubernetes object that is popping up from time to time when it comes to deploying applications on Kubernetes cluster, especially in the Rancher environment, is called customize. Are you
mean
familiar with that?
the customized software?
I think that just software. I don't know. Like it's like as a part of the YAML manifest. So one of the YAML file is customized, and it basically lists all the different containers you have.
Yeah. So customize is actually an add-on, right? It's basically a configuration management tool that adds on into Kubernetes. So it extends the Kubernetes API, right? So it's built in, right, to the command line tool if you want it, right? So they've actually made it part of the like built process. And so, this is kind of like the Kubernetes like open source teams, their preferred kind of configuration management system. They've like added it natively in. Yeah.
So what is the purpose of customize?
So Customize's main job is just to enhance configuration management, like of the pods themselves and the different workload types. That's all it does, right? So like, for example, you can actually see here, like here's the base LDAP kind of file with all of its like volume mounts and containers, and it's got metadata and pieces like that in there. And so what this does is this allows you to add extra features and conditionals into the whole thing. And you can even source other files inside that file, which is not something that Kubernetes does natively. Kubernetes, for example, it just has a feature enhancement, won't allow you to pull other files in to source it inside a manifest. One of the things that Customize adds is little tiny tricks like that, where you can actually source other files that you're commonly using and just pull them in instead of having to write an entire section about like, this volume management or, this secret or whatnot. You can just externalize it to another file. But there's a lot more to it than that. It basically is a configuration management system enhancer for the way Kubernetes does it. And we don't have any classes on that or anything yet. And honestly, I don't think I've ever even used this in production. I just know about it because we were comparing this to another one called Carpenter. So, which is a different tool, but we were kind of like looking at both of them.
I see.
Yeah. So. By the way, there's other things that are not here, like config maps, which allows you to, it's like secrets, but it allows you to do like configuration inside Kubernetes. And so you can just have your app read an entire config file out of the etcd database inside the container, inside the pod. other things that may not let's see is you don't see all the workload types that I was talking about. So we haven't yet talked about all the deployments, which we'll get to at some point in time. There's like network policies that you can apply to enhance security. There's a lot of other components, but at least as far as like getting started, this is a great list. And the main thing you just really need to be focused on is really about pods. That's really what we want to focus on next. Okay. So here's what we're going to do for the next 45 minutes. And it could be less, but it, sometimes it just depends on what pace we want to go at. Is that we should all have access to a lab guide. And the lab guide has 2 labs in it. One is just creating a Docker hub account, like on docker.io, docker.com. And the reason we're having you do this is that hub.docker.com didn't realize how big they were going to get. It cost them a lot of money to maintain that website. So in order to support that, what they did is that they started limiting your ability to pull images down. And so this is actually okay, because this is a great adjunct to the lab, is to have you actually have your own Docker Hub account and then modify your environment so that you can add that account into your system. So the first lab that we have you do is we have you create a Docker account, obtain like an API key, or also known as an access token in this case. And what you're going to do is you're going to take this new access token that you create, and you're going to use it to run Docker login -u, your username, and you're going to put the token into the account. Into your local machine. Now, these machines are accessible by you and me and the admins over at WAS, but don't worry, we're not necessarily asking you to create full access to your account since it's brand new. It does say, by the way, to keep them as the default. You can do that if you want to, or you can set it to read only if you're super concerned about it. Just know that no one's ever going to mess with these systems, and they get deleted at the end, and you can remove your login at the end of the class. And then that's lab 1 is just adding is setting up a Docker login inside your system. Number 2 is that we're going to get started with Kubernetes. By the way, just note that this all happens inside that virtual machine that starts with WA3007 So the one that I asked you all to start at the beginning of class. Now, you're going to log in with your Docker account into this system once again, right? If you haven't already done it. So it's there twice, just in case you haven't done it already, right? And then you're going to open up a terminal if you haven't already done it. And then you're going to switch over to Home WAS Admin Works. From here, they're going to want you to check on the status of Minikube, and then you're going to start Minikube, and it's going to take a minute or two to start Minikube. Sometimes it can, it takes up to 10 minutes sometimes. And then just know that try not to delete or stop that Minikube installation from this point forward. Just leave it running, right? Just let it go. And then you're going to check the Minikube status. And then once the Minikube status shows that Minikube is running and everything's good, then what we're going to do is we're going to actually run through how to use kubectl to get some of the components that we talked about and some of the components that we didn't. So I'm kind of putting you in the lab a little bit early because I want you to get some hands-on experience. And then, if there's a deployment or something like that, we might ask you to delete it. We might ask you to edit a YAML file and enter the following text in. Just know we do actually ask you that you do it manually with the spacing. It's going to drive you crazy. But one thing to note is you got to get really detail oriented, because there's actually 2 spaces between this L, right, and this M. There's actually 2 spaces between this A and this L, like underneath it, right? So the madness of YAML, right? And then we're going to have you run explain, which is going to give you like a description of the fields. We're going to have you go a little bit deeper on the meta there. Then we're going to actually have you apply the YAML file that you wrote up here, which, by the way, is just literally downloading Apache web server, it looks like. In this case, it looks like it's grabbing latest, right? Which, by the way, is bad practice in production, so don't use latest in production. And then you're going to create a deployment manually using Nginx, right? So you've already launched a web server. And you'll see both of them side by side in some form or fashion. And then we're going to have you kick around on the Kubernetes dashboard just to get a feel for the dashboard. Okay. And you're going to mess around with the dashboard a little bit, and then that's it. And then our next lab is going to involve just building a Docker image with a Docker file so we can play with it later. Okay. So we're going to work on labs 1 and 2 right now. So go ahead and get into your virtual machines. And yeah, let's just go ahead and run the lab. I'm actually going to test a few things out alongside you, but I'm not going anywhere. You ask me any questions, you let me know. And in about 40 minutes, we're going to stop for lunch for about an hour. Okay. Questions, comments, any needs thus far before we roll into this?
So, sir, I believe I may have created Docker Hub account before. Can I use that?
Absolutely, you can.
Okay. And you mentioned some access token or something. I can't remember. So if I created, I may have gotten something.
No, you're going to create an access token inside your account. The instructions are all in lab 1.
Okay. Okay.
Yeah, under security. And if you already have one and you have, I think 5 is the limit, if I remember off the top of my head. You
Okay.
just
I can create a new one.
create
Okay.
it. Bless you.
Okay. Thank you, sir.
Yeah. All right, let's see. Go ahead and stop. All right. So some of this you've already seen, so it's going to be a little bit of a rehash, but just to make sure that it's like driven into your brain, right? Is that, here we are, we've got a master node basically, and then we've got worker nodes, and they're hosting pods which contain containers, right? No surprises there. We've already talked about the numbers and the sizes and all this other stuff that could happen inside Kubernetes, but we're going to review the various parts. So we've already talked about clusters and masters and nodes and pods and containers and volumes. We've even talked about namespaces, right? So, the cluster is just the collection of all the boxes. The master nodes, which is referred to or sometimes referred to as masters. That's where all of the Kubernetes internal stuff lives. The scheduler, the cloud controller, the controller manager, all the stuff that manages Kubernetes is on the master nodes. The nodes or the worker nodes are the ones that contain all the pods, which has the containers on them. And we've already talked about the relationship between the containers that are inside of a pod that are sitting on top of a worker node. So cluster is just, one set of boxes. Now, this is where things get interesting. And actually, I think I can probably find a better picture. So let's go do that for a second. I think I was actually looking earlier. Oh yeah. Mr. Mohan, let's use your picture because actually it's really good. So Mohan Pawar is actually a pretty good writer of stuff. All right, so let's talk about this for a second. So this is a very simplified view of what goes on inside the master node and in the worker nodes, right? And it's a great starter point, right? So this API server is where everything goes through. So whether it's the scheduler trying to talk to the etcd database or the controller trying to talk to a kubelet, everything is going to go through the API server. So when we were just now looking at our Minikube installation, you saw API server was listed there. This is where all the communication happens. Now the state of the entire system is kept in this etcd key value store, which is a NoSQL key value store. So, and in terms of what's actually typically on the system, you definitely have an API server. You definitely have a scheduler. You usually have at least one or more controllers. What do I mean by that? You have a controller manager whose job it is to make sure that all the components of Kubernetes are up and running, right? It's job, and it will talk to things directly if necessary. And then you have cloud controllers. So there's a cloud controller for AWS, there's a cloud controller for Azure, there's a cloud controller for Google. And the controllers are how Kubernetes interfaces with the platform that it's sitting on. I believe there's one even for VMware. And then you have at least one etcd data store. If you have multiple master servers, this is duplicated for every server. One of the servers, by the way, if there's 3 of them, one of them is the leader. There's 5 of them, one of them is the leader. If there's 7 of them, one of them is the leader. And by the way, it does require a quorum to elect a leader so they can avoid split brain, which is why they have 2 or 5 or 7 or 9. They have an odd number, and that number could get really weird if you are in an environment and you're using partitions of 3 versus 2. So like you could have 6 because there's 2 in each availability zone. You got 3 availability zones. So if you lose an availability zone, the other 4 know that they're the majority. And so the 2 that are kind of split off by themselves will stop trying to do things to the cluster because they're not the majority. That's what a quorum really gets us, right? One website, if you've never seen like the whole concept of distributed consensus, is this great little website that I love to share with people called The Secret Life of Data. Secret Life of Data. So ignoring my little drawings here, if you want to understand how distributed consensus works with data and with clusters, this is a great little thing to look at. And it's just fun. Like I just gotta tell you, it's just fun, right? It has cute little drawings about, hey, this is what distributed consensus is, right? Imagine that you have a single node system that is trying to, it's a database server, stores a single value called X. Anyway, you can go through this at your leisure, but if you need to understand what distributed consensus is and why quorum is so important, this will help you with that. It also helps you understand eventual consistency in other data sets. So the API servers in play, we talked about the controller manager, we talked about etcd, and we mentioned that there's a scheduler. Clusters can have more than one master, but there can only be one leader, one active master in the cluster. So if we're looking at this picture, if there were 3 here, only one can be king or queen, right? Whichever you want to go after. Now on the worker nodes, just note that there is a kubelet software and there's something called kube proxy. It's not network proxy, it's called kube proxy. There also might be a container runtime if Kubernetes needs to download one to run the container in question because it's in different packaging format. But typically it's going to try and use the OCI compliant runtimes, right? There's other optional add-ons like, DNS or whatever, they'll also show up here. But no, otherwise, these are where the pods are going to run, and they're going to use this kubelet software, the container runtime, and the kube proxy to make that happen. The kubelet's job is to talk to everything else over here. The kubelet's job is also to update the scheduler when something changes by updating what's in etcd. So a lot of the systems, the API, the components of Kubernetes, instead of like talking directly to the controller, they'll talk to the API server and then they'll update a value in etcd. And then that can trigger a response by the controller or by the scheduler. Kind of interesting, right? Approach. Questions thus far?
Sir, you meant, oops. What happened?
Hello?
Yeah.
Hey, Manad, how's it going?
Oh, good, sir. I think something happened. Did you are you showing this Kubernetes architecture?
Yeah, this is the I switched over to a more detailed diagram for Kubernetes architecture.
Oh, gotcha. No,
Yeah.
no, that's fine. I was going to ask you, like in your diagram, you had this bunch of users. So in this case, on the right-hand side, yeah. So what kind of users are these that are directly talking to Kube, the worker nodes?
Sorry, what they're doing is that they're actually hitting applications that are on the worker nodes through a service, right? So there's a service here that kube proxy is surfacing.
Oh,
So that's those, like, that would be like, for example, the node ports, the load balancers that we were talking about before, not the cloud load balancers, not AWS, Azure, or whatever. But the crazy little virtual load balancers that are on Kubernetes, the end users are talking to those load balancers.
The services, the
Exactly.
node port. Oh, gotcha.
Right. And
Or
cluster
load
IP, by the way, is the only one that's not external to the cluster.
Yeah.
So they're either talking to node ports, or they're talking to a load balancer, or they're talking to an ingress, right?
Ingress. Yeah. Gotcha.
Yeah. So even though an ingress is not necessarily a service, it is basically a service. Just to
Yeah.
it is basically a service. Now, remember, if you were on a cloud provider, your load balancer could be out here. But I just want to be clear about this. When you use a cloud provider's load balancer to talk to Kubernetes, it still goes through here.
Mhm.
It still talks to the internal load balancing on Kubernetes. So even an ingress, for example, an external ingress like a AWS, like ELB of some type, even it is actually still going to talk to kube proxy. Okay. So this is just a different, more detailed way to see, right? Here's the API server. Here's the etcd data store. Here's the optional cloud controller manager. If you're not on a cloud provider, it's not going to run one. Here's the controller manager, and then here's the scheduler down here. Everybody's talking to the API server, right? And the kubelet is the one that's facilitating almost all of the communications. Sometimes, by the way, the API server will fall back to kube proxy to talk, but for the most part, those are the points of connection. Notice, by the way, right here, it is talking to the cloud provider API. Note here, control plane, data plane. Note here that the CLI, like the command line interface, the kubectl, is actually talking to the API server because everybody else does. So why wouldn't kubectl, right? Questions of any type? Actually, I really like that picture. I'm gonna post that up here.
Mhm. So so I understand that kube proxy like to provide some networking services, right? Some network based services. So how is this related to like a node port service, for example? Or does this manages those service objects?
Yeah, so the service objects, so you can see the ones that are created over here.
Yeah.
The service objects that are created inside like the system.
Yeah.
Those objects are created, but they're linked through kube proxy. So when someone comes in and hits kube proxy, it then redirects them to the object in question.
Oh, gotcha.
Right? Yeah. So if someone, let's say for example, that someone's trying to get over to the green pod that we have over here. But what ends up happening is that traffic wise, they end up getting like redirected over to this system. The kube proxy knows where this object lives. So what would happen is the kube proxy would probably talk to this guy to talk to this guy. In other words, it would route it on.
Thank you.
Yeah. So every kube proxy knows where to find every other object in the cluster. If it doesn't, by the way, it goes back to here, talks to etcd, finds out where it's at, gets the destination, and then sends it on. So as you can see, this is a very distributed system. So if your networking is not good, like not like your skill of networking, but your network isn't that strong, if there's a slowdown in the network or a disconnect, as you can imagine, the whole thing doesn't really work very well. So. Good. All right, so let's talk about other objects. Controller manager we talked to. Oh, so let's dive into this a little bit more. So the control manager, right? Its job is to actually make sure that nodes are up and running and working and marked as healthy and whatnot. It can actually start nodes if you enable an extension called the cluster autoscaler. And AWS just released something called Carpenter that apparently does the same thing. You've got your replication controller and replication sets that live here. The endpoints controller is actually more for internal use. It says, how do I get to the API server? How do I get to the scheduler, right? That kind of thing. Service account is when you want to put a role onto a like pod or a service, or you want an external service to come in under a certain set of credentials. And then token controller is the one that grants like access tokens, right, to the system. So all of these like features are compiled into a single application called the Kube Control Manager, but they are generally responsible for the configuration, the running, and the health of the cluster components. So if one of the components goes down, it gets marked as unhealthy and is restarted, right? Remember, this controller manager is actually part of the leader nodes. Now, a node here consists of a physical virtual cloud machine. We've seen that already. You know, you can use a command line tool called kubeadm to actually manually add nodes as you see fit. That's actually more of a kind of administrative management thing, less than a like I'm going to use Kubernetes, more I'm going to manage Kubernetes. Nodes, by the way, can be labeled, annotated. You know, you can manage them using kubectl. So pods and containers we already talked about. Interacting with Kubernetes is either going to be through an API call to the API server using the command line tool, or you can use like the dashboard, like which is the dashboard is a product that's maintained by the Kubernetes community. So it is part of their open source project. You know, so you can also use other tools like K8s, Lens. You know, there's quite a few out there actually. So that was just a quick run. This was actually supposed to be done before we did the lab, but I just wanted to like touch on it really quick. Okay, let's back up a little bit and let's talk about how to build a Docker file if you haven't, how to build a Docker image if you haven't done one. If you've done one, I apologize. This is probably going to be a repeat and a rehash, but you know, we do multi-container deployments, so maybe you pick something up. So, okay. After this, we're going to do a lab. So Docker, do we want to talk about Docker is? Here's what Docker is. Docker is like Kleenex for tissue. You know, Kleenex is a brand of tissue, and so people say, pass me Kleenex, they're just saying, pass me a tissue. Now, it might actually be the Kleenex brand of tissue, but it's like sometimes you hear people say, hey, give me a Coke. And they don't care what soda is, they just call it a Coke or a cola, right? Docker's the same thing, is that it's really synonymous with containerization. Now, the thing that's a little different is that while Coca-Cola doesn't own the entire like soda market, and thank God, because I mean, it's tasty, but it's kind of poisonous, right? As far as high fructose corn syrup goes. But, you know, Docker does actually own like 99% of the market. Like, it's ridiculous how much of the market they have. I don't actually know what the numbers are, so consider that to just be me speculating. But I don't know anybody who's really using Builder or Podman. I know they're out there, but I don't know who those people are. And I worked for Red Hat, by the way, last year. So it's not like I'm not familiar with these other projects, because Red Hat does use the other projects. Now, that being said, Docker is nothing more than a standard packaging format. That's all it is. It's just like a container ship, right? A container ship is full of containers that are all standardized. Inside those containers could be tires, bananas, quantum chip. Like, nobody knows what's in those containers. Well, we know, but it doesn't matter what's in the containers. If you have the software to manage a Docker container and you have the right operating system and processor architecture, you can run that container anywhere. Now, Docker will run on any kind of modern kernel. I think we're up to 5 now, so 3.10 is actually really old. Docker can be run on Windows, but usually either using Docker Machine or using the WSL. Oh, what is that? Windows something subsystem for Linux, I think it is, right? And so it actually runs the Linux virtual machine. So it looks like you're running on Windows, but you're really not. You're actually running inside of a Linux virtual machine, which is how you can get away with running Linux containers. Even now, by the way, just to share this. Oh, not that. I should put you on the last page. Oh, yeah. I guess I'm not going to show you because I forgot to start that. But even on Windows, if I was over here, for example, running kubectl or even Docker, this is natively on my Windows box using git bash. The thing that's catchy here is that it looks like I'm running the tools on Windows, but the containers are all inside of a Linux virtual machine. And in this case, the Linux virtual machine is actually VirtualBox. So Minikube is right here inside of VirtualBox eating about 4 gigs of RAM. So it's all inside of VirtualBox. So I'm not using Hyper-V. Just so you know, the reason I don't use Hyper-V is because if you enable Hyper-V on your Windows box, it's going to disable VirtualBox. Now, I don't have a thing for Oracle, so I don't care, but I've been using VirtualBox forever. And so Vagrant and a bunch of other HashiCorp tools only work for me on VirtualBox. So, I can't wait till we can get away fully from using virtual machines, but, interoperability, right? So Docker will run on Linux. Docker will run, or containerization will run on Windows 2019 server and above. You can backport it to 2016, but it's natively in support for Windows 2019. So just a fair word of warning, and I think I said this before, Windows containerization is very different from Linux containerization. So don't be fooled. You're going to be in a whole different world there. It's not as mature. It's catching up fast. It's not quite there yet. Now, you may know this, maybe you don't, right? And it may not even really matter, but I'm going to share it with you anyway. Is that containerization actually is a bunch of old technologies. The first company to actually have containers was Solaris. I was actually touching containers in 2007. And I think I was late to the party, frankly. Solaris, Sun Microsystems had containers way back when. And actually they got it from BSD, which is not, it's a pure Unix distribution, right? And what they were doing is they were taking this concept of kernel namespaces, which is what we use with namespaces now, and this concept of control groups, which allows you to jail, isolate, and control processes by putting them into groups. And it was like all Docker did was make it easy to use, right? C groups and kernel namespaces. Can you all still hear me? That was a very loud beep from my computer. Hold on just one second.
We can hear you.
Okay, good.
We can hear you.
Thank you. Ooh, how weird. Hope that's not a crash. So the bottom line is that all Docker did was just make it easier to use these technologies. That's it. That's it. They were around for a long time. They were even possibly available in the Linux kernel for a long time. So, but not to trivialize this, C groups, by the way, like, controlling memory and controlling CPU usage and all that stuff, right? People were experimenting with this long before Docker put it into a package back in 2014, 2013. But they popularized it, and so they're the ones who are going to get remembered for this. Now, one thing to note, if you kind of like peel back the internals a little bit, is that the Linux kernel in Docker, there is kind of like all this like library and system software involved. A lot of this has changed over the last few years because Docker wanted to add more abstraction layers. And just to say this, like immense gratitude for Docker, the company, because they gave away the most valuable cash cow in the world to make it available for people to freely use. They could have made billions of dollars on this, and they made some money, but they gave away most of the software to the world. They gave away the container runtime interfaces. They gave away the OCI specification. They worked with other people. They opened it up. Like, I mean, that's good work, because this technology, I think last year in 2020, it was estimated that 65% of production deployments were virtual machines, including the cloud natives like Facebook and whatnot. And then what happened is that started flipping. And so now we're looking at, there's actually less virtual machine deployments now, especially across private companies, not the public sector, than there are virtual machines. So you're finding that while virtual machines are still the underpinnings, right? Containers are pretty much how people are deploying their systems now. So it's not like virtual machines have gone away, right? Because we know we need them to run containers, right? And so this is the predominant deployment model. So learning this now is setting you up for the next 5 or 10 years, because until we get sentient talking quartz crystals, this is probably going to be the default deployment model using containers. I hope you know that was a joke. Although if we do end up with sentient computers that are made of quartz crystals, you heard it here first. Anyway. So to build a container that will run, you first need a container image, because that's just like anything, right? If you want to run Java, you have to build like a jar, a war, an ear file. Wait, who's still building ear files? Anyway, a war file or a jar file first before you can deploy, consume it, right? Python has to be bundled. Ruby has to be bundled in some way. You might want to compile a .NET binary. My point being is that you're not going to build your application any differently. You're going to build to an artifact. The artifact from your code build, that's going to go inside of a Docker image along with any required libraries. The image is just an immutable snapshot of you building your deployable software. That's it. So if you were going to do it manually, you'd probably just download like a base of some type, like a jar file, like a base, like maybe Spring Boot, like set up your frameworks and all that stuff, right? And then you using Maven or Gradle or whatever build tool you're using, you have that tool, like take your code, compile it, pull in the frameworks, pull in every other libraries and everything else, test it, and then build the artifact. That artifact then goes into a directory, and then you just run it on the server. The only change with containerization is that instead of putting it directly on the server, you take your artifact, you put it as part of a Docker file, which then puts it in a container package, and you deploy the container package out to the server. But before you deploy the container package out to the server, by the way, you have to copy it up to a repository, and the server is going to pull it down. So there's all these extra steps that you add, and the reason you do that is for scale and repeatability and immutability. So there's a bunch of reasons. But that's what a Docker file does, is a Docker file helps you create a Docker image, which you can then push to a repository and then have an infinite number of machines download that image and run it. So building, using a Docker file, this is a text document, starts with a capital D. Docker build is the command you use to read that Docker file and execute the instructions. These instructions are procedural. Do this, then do this, then do this, then do this. They are not declarative. It doesn't say, hey, give me Nginx version 1.71 based on this. It says, no, tell me exactly what you want me to do and how you want me to do it. Now, in this particular case, this is actually using OpenJDK 8. Where is it going to get the OpenJDK 8 image from, by the way? Docker Hub.
Hub.
That's right, from the hub. Now, if I put a URL in front of here, if I were to type, registry.michaelrishiforrester.com, right? And then put that in front of OpenJDK, instead it would look at an internal registry. But if you don't put a URL in front of that thing, it's going to go out to hub.docker.com, right? It's going to assume that's the thing. Now, the run directive inside of a Docker file says just run this command inside the container. Inside the container, right? So all these commands are going to run inside the container. Then it's going to ask you to add this jar file into the container at this location. And then you're going to expose port 8080. I could put additional exposed lines. I could expose multiple ports. This is a hole in the container. This is a port on the container. By the way, if no one's listening to that port on the application side, then that port's not going to do anything, just so you know. And then when we start this container, what's going to happen? It's going to run Java -jar, and it's going to run this jar file. That's it. Just straight up. Don't get me wrong, these can get really complicated, but that's a pretty standard kind of like Docker file from what I've seen. You basically source it from one place, so always a from directive. You run a bunch of commands, you set a bunch of working directories, you add a bunch of files. You might even, by the way, execute Maven and Gradle inside of this whole thing, so it can just build your source, right? And then you expose the ports in question, and then you set the final either command or entry point that you expect it to do. That's it. Straight up.
What is that minus? What is that minus P for make the option means?
That stands for parent. It means if the directory doesn't exist, I want you to make every piece of it.
Oh,
Yeah. So like opt would probably exist, right? Let's just assume. But if it didn't, what it would do is it would make the opt directory, make the my directory, and make the service directory. So the -P like make sure it makes the entire path.
So, sir, for the different types of applications, obviously the Docker file content would be different.
Mhm.
Is there a common place where we could, like a reference document somewhere that we could refer to, like what goes in a Docker file for a particular type of application?
For a particular application, no, because everybody's build processes are different. Unfortunately, that's no, there's no way. That's a common frustration, frankly, right? Hold on one second. Sorry, I was having a moment there, laughing about the documentation page. The best place to actually start is just a Docker file reference, right? Which basically says, you know, here are your command references, right? Things that you can stick in. This is what the build syntax looks like, right? This is how you like different like formats from arguments, stuff like that. My favorite place, just to say this, to go and like look at Docker files, because you know that's what geeks do, right? Is to go to GitHub actually. And sometimes I'll come out here just to see. And by the way, be very careful with this. Don't pull in someone's Docker file that you haven't read. But like I might go look at Jesse Fraz's Docker files. Now, some of these might be pretty old. So notice the timestamps on this, by the way, right? But like Certbot's been touched recently. I can go look at his Docker file and see. Now, this is actually pretty straightforward. But, you know, here he's just like set a maintainer label. That's actually not super interesting, frankly. Let's go look at another one. Let's go pick, actually the Azure CLI was pretty simple. Here we go. So this one, basically, he's using the Python 3 Alpine image. And obviously he set his maintainer label here. Since this is Alpine, he's doing APK. He's setting up like debugging my setx. And then he's basically adding a bunch of like libraries here, doing a pip install. And then he's deleting all of his build dependencies. And then he's just basically setting up the entry point, which is the AZ command, which is used for Azure, right? So that's my favorite thing to do, is to actually come out here and look at other people's Docker files, because they usually make them pretty like available. And so instead of going from scratch, if I have to do, for example, Postgres, which I think Jesse has actually Postgres. So hold on. He might not. Let's pick something else then. Like Slack. Boy, he does a lot of stuff inside of his things. Here's Slack, for example. Now this is interesting because he is basically showing exactly how he runs his Slack commands, but he's using Debian for this because he's probably running Debian, you know, setting out some environment variables. And then he's using apt-get to grab certificates, you know, the HTTPS transport, a couple of GNU things, right? And then he's removing all the like lists that he downloaded. Then he's setting a locale. Again, notice this is just run commands. And then he's running curl, and then he's echoing into a file, a Slack list, and then he's updating a few more things. And then he's executing basically the Slack command. So what Jesse's doing actually in this particular case is he's actually running his commands inside containers instead of installing them locally. Sounds a little complicated to me, but I've done it with like YQ and stuff because it doesn't run on Windows. So I'll put it into a Linux container and then run the command on Windows, calling it from inside of a Docker container. The point, by the way, in showing you this, Vinod, based on your question, is that because everybody's build process is different, there's no standard location to go to grab, for example, what do I do for a Ruby file or a .NET file or a Python or a Rust or a Go? There's no standard, but you can go out here to GitHub and find it. Find an example.
Thank you.
Yeah.
So, sir, I think what I was looking for, like some of the basic, even this run and all these different commands that are used inside the Docker file. I'm hoping that there should be somewhere, like what does from, I mean, based on what you explained, I think I understand what that from means, and then run and, but there are other, these high level, these commands that are used inside Docker file, right? Yeah. So I think
Yeah.
this is the place probably, yeah.
Yeah. So this is a Docker reference, right?
Gotcha.
Yeah. So you want command label. Notice that maintainers deprecated expose. There's only a few. So I mean,
Yeah.
look, just to look at this, there's no more to scroll down, right?
Hmm,
I think at last count there was like 22, if I remember correctly.
nice.
Right. So there's only 22 different directives. But the problem is that they can call things that can be infinite. Run can call anything.
Yeah.
So that could be any command line that you want to, right? Yeah.
Thank-
Hardik, you've written Docker files, obviously, right? What
Yeah, I
languages
have.
do you mainly support?
Python.
It was mainly Python. Did you package Python up like in a zip file or something beforehand, or did you just grab a whole directory and dump it out?
I would install it on maybe like an Ubuntu image. Sometimes I'd use the from Python 3, but I never use the Alpine ones because they're like they're too slim for what I need to do.
Yeah. Well, honestly, like I don't touch Alpine a lot. I don't really know the APK format like off the top of my head. So I, because I don't know the operating system, I don't really mess with it. Ubuntu though, I could do that all day long, right? Any other languages other than Python?
Sometimes Java. I mostly did like used containers for APIs for creating APIs like Flask or Fast API.
Yeah.
So I
Love that.
packaged that up and then it run the server, and then the other parts of my web server can talk to that API in the container.
Oh, good. Okay. Good. Yeah, that's awesome. Did you ever use the from scratch directive? Did you ever write one from scratch?
Yes, I have. I think some of those was Elk Stack, like Elasticsearch, Kibana, FileBeat. I usually use Ubuntu at first, and then I'd kind of create my own. And then if I needed to put it in a registry, I'd create my image and then use from, and then get it from my own internal registry, or if it was on AWS, get it from the AWS Docker registry.
That makes a lot of sense, actually. One thing I wanted to show you, like this is Docker Hub, is that there's actually, if you do a from scratch, this is for all of you, and Hardik, I know you were just talking about this. There actually is an official image called from scratch. That it looks like it's going to download something. It didn't download anything. It's an empty image, right? This is what you put as the first line in your Docker file if you want to write your own operating system. Or let me be clear about this. You do not need to put an operating system inside of your image. The only reason people do that is so they can add utilities and other things, but it does make the image relatively big. If Windows, it can be up to 4, 5, or 6 gigs if you throw the OS in there. For Ubuntu, you can get actually pretty slim. Same with RHEL, same with CentOS, that kind of thing, right? But if you just want nothing in there and you want the leanest, fastest image possible, from scratch, it allows you to put nothing in there. It's just going to create a file system. Nothing's going to be in the file system, and you're going to have to add binaries as you see fit. Just to say this, most applications do not need an operating system or any of its files. So one of the best practices is that after you've been messing around with an OS-based version of your app, run it from scratch and add the stuff in there that you need. You're going to find that that image is going to be 10, 20 megabytes in size, and it's going to deploy like that. Even with that being said, by the way, I'm sure all of you have experienced this. You've probably taken a couple hundred meg image and it's probably also still run pretty fast, right? But just know that the next level above using an OS-based image is to use from scratch instead. So it's a no op in the Docker file, by the way. One other thing I wanted to mention inside the documentation, slim some of this out here. Let's see. Is that in this Docker file reference, one thing I think it's worth kind of understanding is that there are two commands that can end cap the end of a Docker file. So when we were looking at this just a minute ago, notice that here we're using commands, right? Now, the interesting thing is that command is really just used. It's got three forms, but most people, by the way, use the first form, which is we're going to put everything in double quotes, right? And separate it. There's a reason for that. It's more of an optimization thing. So there can only be one command instruction inside of a Docker file. If there's more than one, then only the last one's going to take effect. The main purpose of a command is to provide a default for executing a container, right? In other words, right, you can include an executable or you can omit an executable, but you're going to have to provide something. Either entry point or command is typically going to have to be somewhere in the container if you want it to do something, right? So, you know, just note that there is this complex interplay between the two, because entry point, which again also uses the same format as command, it just uses that same double quotes with a comma. It basically allows you to configure a container that will run as an executable versus running an executable like inside of a container. So for example, if you're going to invoke the container on the command line, you're typically going to use entry point. If you're going to run it as an application like a web server or whatever, you typically use command, right? It just behaves differently, right? And so what it does is how it appends all of the command line arguments to the actual executed like command. Think of it like this. Let's say you're on the command line and you want to run YQ, and then you put a bunch of commands after it, but YQ is an alias to a Docker run call. If you use entry point, then appending those commands in the command line actually works. If you use command CMD, it doesn't actually work that well. It actually throws an error, right? And when you put the two together, right, there's a whole listing here, right? Which basically says you should have at least one command or entry point command. Entry point command should be used when the container is running as an executable. Otherwise, you can just use the command if you want to, right? Now, just note that there's this whole complex table that will show you the interaction between the two. And I got to tell you, I would just avoid that. Just don't do that. If you want to run it on the command line because it's not a running production application, just use entry point. If you're going to run it in production as an application, just use CMD. Can you use either for either one? No, you can't. You can still use entry point for running applications, but you're going to have problems if you try to run command as on the command line. Now, that sounds weird and counterintuitive, but just know, in general, just use command unless you decide to mess with stuff on the command line, then use entry point. Okay. All right. So that was just us parsing out Docker files just to a certain degree. Now, we saw on one of the other GitHub ones that we were just looking at where he had environment variables and it just had the env directive, right? So you can use the standard bash modifiers, right? There's probably not much more to say about that. We're probably very familiar with environment variables. Here, by the way, is an example of some environment variables where they've set, you know, foo equal to bar, right? So then when they interpolate, right, they're doing a string interpolation against foo, against the variable name, it's going to return bar, right? Here they've added $foo, right? Standard interpolation. Now, this is interesting because the arg instruction is going to define a variable that users can pass at build time to the builder, right? Like using like build arg or whatever. It's useful when you need to change the customization of your Docker file at build time, right? So like, for example, see where it says arg username? It's going to look for this username variable in the Docker build command run. So when you go to run Docker build, it expects you to have this build argument, so explicitly username, set and defined, and it's going to read the Docker file that's in the current directory. So what it's doing here is it's looking for this argument, right? And then you can actually use that argument later on, right? So this way, without editing the Docker file, you could pass a Docker file to somebody else and say, hey, just change environment equal to prod, and it's going to pull a whole different set of things versus environment equals dev or environment equals QA. So this arg variable allows you to set, at build time, different flags without having to go in and edit the file in question. Now, I gotta tell you, I don't necessarily use that a lot, because if I do this, I do it programmatically, and I usually do it in a CI/CD chain. I have seen people use this, but it's not something I use a whole lot. Now, I mentioned earlier that you could call in your Docker file another tool that gets downloaded, run that tool, take the output, and then put that into your actual image and get rid of the other like build image, if you will. So here's a multi-stage build. Here's an example. So this is Gradle, which I think everyone's familiar with, right? It's used to build Java applications. And what happens is that they're actually sourcing the JDK10 Gradle app, right? The image, if you will, the container image. They are copying in, love how it says change on equals Gradle. They are copying pretty much anything in the root directory into /app, which actually is just Gradle, right? And then what they're doing is they're actually running Gradle, and they're running it against, bootjar. Oh, I see what they're doing there. They're actually taking their application, they're sticking into app, because the Gradle file is already in there because it's in the image, right? Then what's happening is that then they're running Gradle, and then they're running bootjar. Now inside this directory, in the app directory, they have run Gradle, and they haven't specified any tasks, but like it looks like they're going to do specify bootjar, right? So it's actually going to go through and probably create a bootable jar file, I guess. And then what's happening is that they're going to download another image, use that as the source, expose to 8080, basically specify a temp volume, set some library arguments, right? And then what's happening is they're going to copy from builder. That's just an alias. From builder, they're going to copy the app build libs directory, and they're going to stick it here. That will have grabbed this jar file that got built up here. And so now they have an entry point where they can just call Java jar and this jar file. So let me make sure I'm clear here. They actually built this from a previous image, copied what was in that previous image set builder, which was labeled up here as builder, pulled the jar file over, and now they have the jar file embedded into this image that they've created. So when this is created, all of the extra junk that was created like while running the creation is all in this image, which is discarded. Like it got discarded after it was used. And that's a multi-stage build, right? Just to say this, by default, stages are not named. You can refer to them by their integer number, right? That's a pointer, by the way, to every from instruction. So if you have 4 images that you use to build your stuff, the first one is 0, the second from image is 1, the third from image is 2, so on and so forth. You can label these with aliases like we saw here with the as tag, right? So this is build environment. Then they can actually copy from the build environment compiled code and stick it in their root directory. In general, I don't see people do this. I see them doing this where they label their stages, right? Let's see. By the way, you can specify a target build stage. For example, the following command is going to do a Docker build, but it's only going to build to a certain level, like a certain stage. It's going to build to that stage and then stop. This is great when you want to debug, right? You want to use debug symbols, or if it's a testing stage, but when you build for production, you might use the same Docker file and you go all the way, you don't go halfway down. So just think of this as a way of you creating stages, controlling the execution of staged Docker files. Any questions thus far about like this whole multi-stage build concept? Let's pause here for a second. No? Okay. Okay. The run command, which we've seen several examples of, usually it's just run and then the command in question, right? So what do you use the run command for? Well, anything that's like non-interactive. Like you wouldn't run VI, right? Because you need to interact with VI. But anything that can just run without user intervention, that's what you're going to use the run instruction for. If we go back and look out here, let's say we go back to, well, not that, because that's GitHub. Let's say we go back to github.com. We go back to Jesse's little repository on Docker files, right? Let's see what else he's got out here. Come on, Jesse, what else you got? So that's a Git server. I wonder what that one does. Let's take a look. So not a multi-stage build, so not really looking for. Let's see if we. Let's go look at some. Oh, you know what? I don't want that there. Let's go look at all of GitHub. Here we go. Here's a Java multi-stage Docker file. So remember what I said earlier, Vinod, or maybe it was Sean. Sorry, I forgot who was asking. You can actually find what you're looking for just by typing it in GitHub, right? Here is a Docker file. Let's go see what this one's got. So from Maven, so they're using Maven instead of Gradle this time. They're going to make a source directory, right? Set a working directory, copy everything there into, that's interesting. Oh, into the working directory. That's right. I forgot. Once you set a working directory, by the way, dot means, the second dot means working directory. And then you're going to skip all your tests, do a Maven install right towards that particular goal or target. And then you're going to download the Tomcat image. By the way, this is horrible. You know why? Because it's downloading the latest Tomcat at all points in time. If you don't put a label at the end of your images, like a tag, it's going to download latest, which means it's just going to continually update. They're going to set your working directory web apps, and then from the Maven, right, you're going to execute, copy this in, and then you're going to remove root, and then set the root.war. Oh, you're going to run it. There you go. And they're going to run the root.war. Huh. This actually doesn't do anything. It just like generates a root war file. Huh. Bottom line is that, see this run command? That run command can be anything you want. I don't see people typically sticking like the exec form with the double quotes and the commas around the run commands. I see them doing it for command point and entry point. Notice that this container is not going to do anything if you don't give it a parameter, like run the war file. So this one is just going to run through its process. It's purely for build, and then it's not going to do anything else. Let's take a look at this one instead. So this one has an entry point to it because it's going to start Tomcat. Notice all of the run commands here. Your only limit, by the way, is it non-interactive, right? Notice that he's running, he or she is running multiple commands on the same line. One of the reasons to do that is that every time you put a change to the file system onto a Docker file, you're going to create another layer to that Docker file. It doesn't necessarily, like, it's just an administrative layer, but it creates some level of independence when you do that. Like every time you add an instruction, it usually creates a layer to your Docker image. So
in this example, is he just trying to create a installing like a Tomcat server or creating a Tomcat server.
Yeah, that's exactly right. Right. So the first thing he's doing is that from Ubuntu, he's grabbing all the Java stuff that he needs. Then he's installing Maven, right? And then he's of course installing wget, which he then uses to grab version 9.08 of Apache Tomcat. Then he makes a directory, moves Apache Tomcat there, untarballs gzips it, right? Then adds a Tomcat user, adds into the Tomcat group, CDs into opt Tomcat, which where did he make that at? I think he made that up here somewhere. And then changes the permissions on it, change the ownerships on it, and then basically sets it to run. He runs the startup.sh.
Mm. But if I was to, let's say, create a Docker file to deploy a WAR file, then I would probably start from maybe Tomcat image itself, so right, directly, and then copy my WAR file there and build that way, right?
That sounds right. I mean, that could be better actually, because then Tomcat's
Yeah.
already there, right?
Yeah.
So then just pull your war file, compile your war file, run Grave or
Yeah.
Maven, whatever you're doing, then just dump the war file in there and then just kick the image up and then there you go,
Yeah.
right? The only thing is that what if you don't trust this installation of Tomcat?
I see.
You might need to make it yourself, right? Most
Yeah.
enterprises, by the way, will not let you pull from hub.docker.com. Hardik does, do you know, and maybe you guys both know, maybe you all know, I have no idea. Hardik, do you know if you can pull from hub.docker.com to pull down images?
It kind of depends. If it's like a development environment, it's okay. But if it's like in production, usually using the internal Docker repository that whatever the company's using.
And I think that's Artifactory, right? Is that what they're using? Do you know?
Yeah, Artifactory, and I think my company uses something like Nexus.
Yep. Nexus is the other one. Do you work for Booz Allen, Hardik?
Yeah, I do.
Okay. By the way, I'm assuming, do all of you work for Booz? I think you all work for Booz, yes?
Correct.
Yeah. Yeah. Okay. Just want to make sure. Okay. So yeah, so I gotta tell you, Vinod, if you trusted this, then I would probably just do it that way. If you didn't, and a lot of companies, what they'll do is they'll have, like Hardik was describing, like a Nexus or Artifactory repository. And what it will do is it actually pulls from hub.docker.com, but it runs everything through a security scan and then pulls it into the repository. So oddly enough, you can actually pull public images through some of those proxies, but they'll run it like Claire or StackRox or some other kind of like open source scanner against the images to make sure they're sanitized.
I think that's exactly what happens in our, especially in our customers' environment. Like they, on a nightly basis, they pull from this docker.io or some Docker's, hub repository. They run the security, and the next morning, anything you add today to Docker Hub is available in that environment after scan. All the stuff is taken care of.
Yeah. Good. That's the best practice, because then you get the benefits of using an open source kind of like community, but it's sanitized in a way that meets the standards for the enterprise. So it's ideal. So, I mean, I don't know if you've ever run into this, but it's really frustrating when you're like, everyone's excited about some new tool that's out there and you can't touch it because security hasn't approved it yet. And there's no rancor about the fact that they need to do their jobs, but you're like, man, if I had this tool and I could use it, it would make things like a lot easier,
Yeah.
Yeah.
I think that realization is now there, and they don't want to be left behind. So.
Yeah, well, and when all the technologists are working in the private sector, it's like, yeah, that's pretty frustrating, right? Got to keep up with what's going on out there to a certain degree. And I mean that from people who are incepting these projects, not the workers like ourselves who are doing it, right?
And to some extent, these cloud providers are enabling too, right? Like they're serving customers and they're bringing latest and greatest. So
Well, and I will say, cloud enabled DevOps. And I think the cool thing is that I love that the cloud providers have versions of their platforms that are available for government and like super tight government use. I had a buddy tell me the other day, he works for the NSA. He was like, you know that we had AWS, and this is apparently public knowledge. I didn't know this. AWS was apparently hired by both the CIA and the NSA to create private, like non-gov cloud, but like their own private clouds for them. And they weren't allowed to touch it. They could only provide design guidance. The NSA and CIA technicians had to actually build the whole thing. I was like, really? That's cool.
in fact, it's a public, it's an unclassified information called C2S. So if you can Google C2S and you'll find that information. That's the cloud they built, these AWS helped build.
C2S. Cool. Thank you for sharing
I
that.
think if you Google it, you get all the information.
Okay, I'm gonna look it up. That kind of thing interests me like to no end, right? He didn't say that, by the way. He didn't say C2S. Probably didn't know.
Yeah.
Okay, so run commands unlimited, right? Your only limit is your imagination, and again, not interactive, right? I think as part of this though, like I said, there's only like 22 directives inside the Dockerfile listing. So, the run command is really the meat and potatoes of where things happen inside the Docker file. Don't get me wrong, command and issue point for ending, copying files in is super useful. Setting environment variables is awesome. But the run command is where kind of all the magic happens. It calls the tools that make it work. Expose, by the way. So basically it informs Docker that the container is going to listen on the specified network port when it's run, right? It basically says, hey, Docker, this thing is going to listen on port 80 because the application inside is listening on port 80. So, if you want to send traffic to it and it's on port 80, you can do that, right? Yeah. I mean, it's interesting because it's more like a, almost like a label or a tag that says, hey, this port's available, right? You can also buy the specify IP on the command line if you want to, when you run a particular container, to explicitly map a single port. By the way, host usually comes first. So it's usually host and then container. So
in this example, you have a minus P80:80. So the 80 is the local host, like first one is local host.
yeah, so it looks like it's going to be local host 80 and then it's going to be container 80, right?
Got it.
For both. Now this is interesting because it looks like it's calling an image that I'm assuming has Nginx in it. And then what they're doing is they're running a command inside the image called service Nginx start. So in this case, they're actually running that command inside the image. Let's see, here's another one where they're specifying the protocol type, right? UDP versus TCP, so both, right? Just know that regardless of what's in the Docker file, this statement is very true. You can override what's in there if you need to, if it changes ports or something shifted, right? General rule of thumb, if you're not really sure what's going on, it is useful to get inside the container and see what it's, is it running? What is it listening to? That kind of thing. So that's expose. So we went from run to expose, and now we're talking about copy. Copy requires practically no description because we all know what copying is. The only thing that's interesting about copy is that it does have a few actually command line flags, including change ownership, as you can see there, which includes user and group. So otherwise, it supports all the wildcards and the, asterisks and all the rest of it. So what's interesting is that copy basically copies new files and directories from source and adds them to the file system of the containers at the path. I mean, pretty much the add does the same thing, right? It basically takes the new files, the directories, and URLs, and then adds them to the path. I see a lot of people mainly using copy because they can remember copy and not necessarily using add. One thing that always fascinates me is that when we go in here and look at the documentation, And let's go take a look at add, for example, right? So add has two forms, it has the change own and whatnot, right? And it basically just adds into the file system. When you look at that and then you look at copy, well, pretty much seems to be the same thing. I don't know that I found a distinction between the two. Have any of you ever found a distinction between copy and add?
I think I remember it, but I don't actually remember the exact difference anymore.
Yeah. Yeah, it always just threw me for a loop. I just use copy for everything. All right, now we're going to get into commands. Okay. So the command instruction has three forms. I got to tell you that this is, and actually it says that good. This is the form that pretty much everybody used. Now notice that run, which we saw before, actually supports the same format, and nobody uses run with that format. Right? They always run just like run is just the command. Whereas when they use CMD, it's like explicitly like, this is what we're doing, right? So there's only one command instruction allowed in the Docker file. Technically, that's not true. You can put as many command files as you want, directives in there as you want. It's really just the last one that's going to take effect. So why even put more than one at that point? By the way, one reason you might put more than one in there is that you might have the stages of your builds, like you have a multi-stage build. The end of one stage might have a different command entry than another stage. So, which would mean that would be the last one, right? So just FYI. Entry point, that's the same thing. Now remember, entry point is really used for when you want to run a Docker like command as if it's part of a command line. Whereas CMD, which oddly enough means command line for the most part, is actually used when you're running an application, in production. Notice here it says you can override the entry point command by using the following commands. You can override the command with the command. So, oh, yeah. It acts like you can't override it, but you can actually.
In that example, the entry point basically starts that Java program that is inside that Spring Boot app.jar, like a main. Maybe is that right?
Yes. Yeah, that's exactly right. Since this
And
is the
then-
last entry of the commands,
Yeah,
it's going to run it on 8080, both on the host and the container.
yeah.
Here's the image in question. It's going to remove the container once it's shut down, and it's going to be run in an interactive terminal mode as well, TTY mode. So you're actually going to be able to interact with it.
I see. So I'm sorry. So I think so that line, the one that started with entry point, and then line that starts with Docker run. The Docker run, that's like a command line thing, right? If you want to do from command line.
So if you're not using Kubernetes and you're using Docker, you can actually just run commands just by running Docker run. And what it will do,
Gotcha.
yeah, like to give you an example,
Oh,
just to make sure hey, look at that. Is Minikube working? Hold on one second. Okay, good. So by the way, when you run Minikube, you can actually use the Minikube to actually run your Docker commands instead of having to run your own Minikube installation.
mhm.
So what I'm doing here, and then Docker PS, let's just see what we got. Okay, good. So there's a bunch of stuff there. So if I if I do a Docker run, and let's just say I'm just going to do Nginx, right? You can't find it locally. So in the virtual machine that I'm actually connected to, it went and downloaded Nginx from hub.docker.com, pulled it down, and then once it's verified everything, because it's doing the layers now. So Nginx, I think, has like 8 layers. It's pulling down all the different layers. Actually, it looks like it's maybe 6. So 6 layers there. Once it pulls down all the different layers, it's actually going to run the Nginx container. So in this command that we were just looking at, bear with me. What we're doing is that it's actually just running my image. It's running my image, but I'm adding some pieces to it where I want it to run on port 8080. I want it to remove the image when it's done with it, and I want to run it in interactive mode. So that's what the Docker run command is doing, is it's actually just running my image. So if we go back and look at my example, it actually started Nginx. And since I didn't put it in detached mode in the background, it took over my terminal, and it's literally running right now, and it's running 1.2.4, sorry, 1.21.4. So Nginx is now listening on the default port, which I guess I assume would be 80, right, on the system, but I didn't expose any ports there either, right? So. Any questions there? Okay, excellent. All right, so remember that you can override command and entry point, both by define what should be done, but notice that this reiterates what we said earlier. Entry point is when you're going to use it as executable. Command should be used when you're actually an ad hoc command. Let me give you an example of running a Docker command has an executable, right? Just give you an example, which I think is pretty fun and funky. So YQ, I'm gonna kill this this Nginx, by the way. By the way, notice if I scroll up, there'll be an Nginx container here now that was downloaded, right? Sorry, this is the container. If I look at my Docker images, wait, did I do that right? Oh no, I'm doing something wrong here. Hold on. There we go. Nice looking. Notice that Nginx was downloaded here. So created 6 days ago. Woohoo! All right, let me show you an example of using Docker as an executable. So I have a command called YQ, right? That what it does is it basically does it allows me to break YAML into pieces and kind of pull it out as like as different like specific like sections of YAML, right? Probably the best way to say it. If I look at my, I think it's my bash RC. Oh no, let's try that again. If you look down here, see where it says, see where YQ, oh, that's right, I rummed it out for some reason. See where what it's doing here is that I'm setting YQ as a function, and then I'm running this Docker command, right, called YQ. Now, the reason I'm doing that is this Mike Farrow YQ, which is actually out on hub.docker.com. It runs an entry point command that specifies YQ. So this is set up so that every time I run YQ, now right now it's like blanked out, I can actually like run all of my executables as Docker files that just get downloaded on my system at the time that I need them. So this is a way in which you can actually keep binaries that maybe are not native to your operating system, or that you just want to keep so the operating system doesn't get too heavy. You can actually keep them out as executables that are in their own isolated environment. You also can increase security against those executables by keeping them in their own isolated environment as well. So notice that I see what happened here is, and thank God I put comments in my own stuff, right? This was an experiment with using Docker binaries as aliases. YQ is now installed locally. So if I, if I get out of this and find out if I do a witch on YQ, I actually installed it via Chocolatey. Once it became available on Chocolatey, there was a period of time where you couldn't get it, right? So good deal. So that's an example of like how you can weave in a Docker container that has a binary in it running entry point into your local command line and run it on your system. So just as a simple example. Okay. Volume can be pretty interesting because the volume instruction allows you to create a mount point for a, for a system. Notice here, by the way, is that from Ubuntu, we're gonna make a directory called my volume. We're gonna echo a greeting file into this volume, right? And then we're actually gonna create it. So what this is gonna do is this is gonna create a new mount point at my vol and copy the greeting file into the newly created volume, right? Now, this is gonna create a Docker volume, not a Kubernetes volume. So just so you know, the Kubernetes storage system works similarly in name and different in execution than Docker volumes. Docker volumes are typically local files, especially now. Kubernetes volumes are typically remote storage systems connected to a cluster. So this is really a little bit out of date unless you're just doing local development, right? Now, once you have your Docker file defined, including your, entry points and commands or whatever, you can usually do a Docker build dot. That's not a joke, by the way. If you don't want to call your file capital Docker, file, you can use the -f to get there, right? So just know that Docker build will get you to a couple of places. And in this particular one, wow. Sorry, I'm a little out of control, apparently. Hitting the wrong buttons. In this particular case, notice that the -t actually creates a tag. In order for you to push your image from your local system up to a remote repository, it needs to have a tag on it. The tag is, the version and the name of the container. You can see this actually, like if you go look at your Docker Hub account, like, where's mine? Oh, where was I? You know what? Let's just go there. If we go to hub.docker.com for my primary account, I don't think I have a whole lot in there. So here's an API service that I was messing around with that I uploaded like 6 months ago, right? And so notice that it's Spartan Stage API. If you click into this and look at it, right, there's like the latest tag and that's it. I haven't added any other tags to this. If I add another tag and I push it, right, what will happen is that number will show up here. When you look at most systems, like Redis, for example, by the way, try to use only official images here. And you look at the tag section, latest is still here, but notice there's more like the version number, major version number. By the way, look at these sizes. 40 megs, really? It's really tiny. So just know that T creates a tag on it. It's not required, but it's usually good practice to actually put a tag on the system, okay? On the image as you build it.
Can we put our own tag or we have to let Docker build pick a tag for us?
Oh, no. Tags are completely arbitrary. You pick them. Tag it whatever you want.
What did we do here in this example? Where you just say -t and giving oh, that's the name of the tag.
Yeah, that's, oh, sorry.
Right?
Yeah, so this is usually like the user or owner of the image. Here's the thing itself, right? You can put you can put a colon and then an actual like number after it, just
Gotcha.
right. Yeah, because they're missing a deeper tag expression here, right?
Mm-hmm.
So,
okay.
And this can be whatever you want it to be. Most companies have a tagging convention or a standard that they'll follow. So it'll be like BAH/ something, client app, version 1.0 or version 1.1 or some variation thereof. Let's see, when you run build, it's going to be run by the Docker daemon if you're on Docker, which most of us are. And then it's going to send the content entirely to the daemon. Do not use the root directory as the path because it will try and copy. And all of us do this at some point in time. We put the entire contents of our hard drive inside of a Docker file. Nothing more fun than realizing when you're starting off early on that you just stuck your whole drive in there, and you wonder why the image is 10 gigs in size, right? Do know that you can create what's called a Docker ignore file, which will automatically exclude files like .git and other files out of the directory, especially if you're pulling from a repository. If you want to view images, you just run Docker images, so straight up. You actually saw me do that earlier. It will, by the way, look for the Docker ignore file before it'll actually send the contents. So it'll exclude files that are in there before it sends files over to the container, right? For example, you could say anything that starts with temp in the immediate subdirectory, temp 1, temp A, temp B. You can use regular expressions here if you want to. Here's some best practices. 1, please set version numbers. Please. It's not from OpenJDK. It's from OpenJDK 8 whatever 4-Alpine, right? Set a user. So you can basically, add a user, set that user as the user that the process is going to run as. Otherwise, the process is going to try and run as root. If you're in a rootless environment, that's not going to work. So suggest you do something else. Make sure you verify downloads. So maybe like verify the hash or just verify the download is there. It's not bad to put a little bit of logic into your Docker files. By default, if you don't specify a port, it's not going to publish anything. You can use the -p flag or -- publish if you want to. Here's the example. Notice here that they're specifying the IP address on the host that they're going to use. And they got the host, right? And they got the container. You can have multiple -ps if you want to. The official Docker documentation is pretty good, actually. It's not rife with the most complete examples in the world, but it's pretty solid. So it is worth exploring. We talked about, by the way, having a registry. So moving beyond like the directives of Docker build and the Docker build command itself. Note that once you build your image locally, you tag it, you then push it to a repository. So, you can create a local registry to make images private. We talked about this with Artifactory and with Nexus. We've discussed this already. You can run your own local registry, but you're kind of already doing that already. So I don't know why you'd want to do that again unless you're just testing registries, right? Note here that they tagged an image that is already running, right, inside of a repository. So here they're running a registry 2. They pulled Ubuntu 16.04, then they tagged Ubuntu 6.4 as localhost my Ubuntu, and then they pushed my Ubuntu up.
Well, sir, what is the -d option?
Means run it in detached, so run it in the background.
Oh, okay.
Yeah. In other words, that command's not going to it's not going to crash, right? So let me show you. Oops. Whenever I get here, it always captures my terminal. It cracks me up. So what it's doing here is remember how Nginx, I didn't put a -d, and so it ate my terminal. It took over the terminal, like it wouldn't let me do anything until I Control-C'd out of it. Here, what it's doing is it's downloading the registry, and now it's running in the background.
Oh, cool.
So if I do a Docker PS, guess what? In addition to all the Kubernetes stuff, guess what's now running in the background, right? So it's been up for about 5 seconds. It's bound to port 5000, and now it's actually up and executing. And compare that to the Nginx one that's actually like just sitting right here. Well, it's also up actually. I guess when I Control-C out of it, I didn't kill it. Interesting. But that puts it in the detached mode instead of it eating my terminal. So that's what the -d does. All right. Let's see. Remember that you are running your own local cache of images, right? So in addition to having access to a remote registry, you're going to have your own local cache. It works just like Git. You know, in Git, when you clone a repository, you pull a copy down and it's on your local system, and then you can push changes back up if you want to. It works remarkably similar, right? So in this case, we are removing the 1604 and we're removing, oops, this local image. And then we're going to pull the image from our repository. And then we're going to stop the local registry. And then here we're just like deleting the registry. Yeah. So if you want to deploy to Kubernetes, by the way, one thing that is worth mentioning is that you can actually like use generators, which are basically just imperative commands where you're like, hey, I'm going to use, instead of Docker run, you can use kubectl run, right? So you can just create your own deployment inside the system if you want to. Now, notice in this case, the image they used actually is Nginx. Same thing here. They created another deployment Nginx, right? But they gave it a name. Oops, they gave it a name this time. So they created a deployment and they called it Nginx, and this can actually be scaled. Then they exposed a port here, target port 8080, local port 80.
So in this, the last line, the highlighted one,
Mhm.
when you say port dash dash port 80 and then target port 8080. So this dash dash port 80, is that the local host port we're talking about?
Well, remember, these are on remote systems, right?
Yeah.
So what this means is that in the container, 80 is going to be listening, but in a sense, it's going to expose 8080. So 8080 is going to lead to 80, right?
So locally, if I wanna access my, let's say it is assumed, well, this is Nginx, in this example, it is Nginx, it's Nginx web server, right?
Right.
So Nginx runs on port 80. So the container inside the pod would be running on port 80, but developer user will access from his browser on 8080.
Right. But what IP address you would put in there is up for discussion.
Yeah.
If it's a single node, you just put the single node in there, right? It depends on
Yeah.
where the pod is running, right? Usually at this point, you'd put a service in front of it, and this, right? This does expose it. I think by default, it does it through node port. But just to say this, if port 8080 is bound on that system, you're not going to be able to run this command. Does that make sense? If there's 100 other pods on there and one of them is bound to port 8080 on the host, you can't do that.
Uh-huh.
Yeah. So typically this is where we put services in place to kind of avoid that kind of challenge.
I see.
The main thing that, by the way, this is not how we manage Kubernetes. We mainly do it with YAML files, right?
Yeah.
So this is not the way we do it. This is just for messing around, just to be clear.
But sir, inside the YAML files also, maybe, some of the older YAML files, I don't know which one we can call old or new. So I noticed that they use, even inside the YAML, they use port and container port and target port. So
Mhm.
it's a little bit, if you could help clarify either now or later, that would be appreciated inside the YAML.
Oh, we will. We'll talk about in the YAML. Everything we're going to do after this point is mainly revolving around editing and exposing the YAML files, not really
Sounds
through
good.
command line, right?
Sounds good.
Here, by the way, we actually did this in the lab. We actually, right, accessed a deployment. We created our own MyApp YAML file, and then we applied the YAML file, which then rolled out Apache web server, right? Notice that instead of doing like apply or whatever, we did a create function with this. This is still an imperative way to do it, but this time you're using YAML files to do it. So this is method 2. Method 3 is where we're going to apply a YAML file, right? And this can actually typically be modified. Whenever the word create is inside the equation, you're saying, I want you to do a very narrow, specific operation. When you use apply, it actually is going to wrap things like deployments and stateful sets and other workload types around the thing in question. A lot of this behavior has changed a lot over the last few years, but I think in general, it kind of gives you a good feel for, you really want to do it by method 3 is the declarative way. Create a YAML file, apply the YAML file. If you need to make changes to the YAML file. GitOps requires you to have files that can be checked into repo that then can trigger an ingestion of those files, a process, maybe even some testing, and then it gets rolled out to production, right? So writing things in YAML files is pretty much how it's done for almost everybody. And if you're going to do it outside of a CI/CD pipeline, kubectl apply is how we approach it. Oh, here's another one. And this is, by the way, one that doesn't work inside of Git Bash inside of Windows. But like if you want to execute a pod name and then like execute something inside of it. So has an example. Where's my terminal at? That's right. Sorry. Had to let you go. If anybody else is experiencing that, that seems pretty slow, actually. Let's say I want to run Ubuntu, but I also want to run bin bash inside of Ubuntu. So what happens here? Oh, all right. Let's do this instead. Let's use that command. Let's do kubectl. Oh, that's right. I was going to use that using Docker. What was I thinking? Getting all the things. Run it now? No. Rats. I'm sorry. I'm getting everything confused in my brain. I've been spending too much time doing other things. kubectl exec it pod name and the command to execute. So sorry, I'm just going to do it manually since I'm having some difficulty over there. So what this does is that when you run docker exec or kubectl exec and you have a running container, oof, I don't know what's going on with my fuzzy brain. What happens is that with IT, you're running it in an interactive mode, right? And then if you pick a container name, let's say Ubuntu, and it's got a file like a command binary in there, like bin bash, you can then run the command to execute it. And what it will do is it will just execute right then and there. So, you know, to go like back to my particular example, if I'm using Docker and I want to do a Docker exec, and let's say it's Ubuntu, right? This command will actually have to work if I actually have Ubuntu actually already up and running. So if I do it again, it'll do the same thing and say, look, there's nothing running. What are you doing? If I do a Docker run, dang it, I misspelled that. Let me stop that for a second. 1 second. If I do a Docker run, what it's going to do is that instead of me having to now run it and then run an exec command, what's going to happen is that it's going to run bin bash as if I had run Docker exec against the Ubuntu command. So now what's happening is if you look at my command prompt, it's no longer this colorful prompt. I'm actually inside the container, right? And if we look at what's going on inside this system, notice that I have a whole different kind of overlay file system than if I was inside of a CentOS box. So I'm actually inside the container itself. I'm not actually in my host. If I exit out of this, the container will stop. And notice that if I run that same df-k, I'm actually back in CentOS. So typically we'll run the exec command if the container is already running. We'll run the run command with the same thing if we actually just like want it to run in the background. Now, Ubuntu is an interesting container because, by the way, Ubuntu won't do anything. It'll immediately shut itself down unless you kind of give it a command. So let me give you an example. Let's say that I don't actually want to run Ubuntu in the foreground and I want to run it in the background, but I want it to sleep, let's say for, I don't know, let's say 600 seconds, just to mess with it, right? It's already running. And if I do a Docker PS, what should happen is that you should see up here that Ubuntu is up and running. And so notice it's been up for 4 seconds, right? There it is. So now what's going to happen is that I can do the Docker exec command, right? And I think it was gifted Richie, is that right? I think that's what it was. They give you these funny names that you can actually use to refer to them. Gifted Richie. Hey, I got that right. Good. Sleep 600. And so what I can do is I can then go troubleshoot and say, why is this thing not running, by doing a git bash? And now I'm inside the container. And if I do a ps-ef and I grep for sleep, it should show the original sleep 600 command that I actually ran to get the container up and running to begin with. So what happened here is that I actually used Docker exec to get inside of a running container. You can use kubectl to do the same thing. You can actually get inside of a running container with kubectl exec, and you can hop in the container to troubleshoot the container if it's not working for some reason. Now, that's probably one of the best ways if your log files and your events for Kubernetes are not telling you what's going on, right? Now, I will point out, by the way, that process number 1 is actually called sleep 600. So someone tell me what's going to happen when 600 seconds passes after that container's been running for 600 seconds. Anybody know?
It'll probably end.
That's what I was thinking too, right? Yeah, so what will happen is that since that's process number 1, and that's the primary process that the container is looking at, Ubuntu, by the way, has no command or entry point directives. What happens is that the minute that that command stops running, it's going to crash the container. Although it doesn't seem like it allowed me to kill that for some reason. Might miss like using the man command. Oh yeah, no, I don't have command on kill on here. Yeah, so it should kill that container after it runs out of time. So remember, exec will allow you to execute binaries inside the container itself. By the way, you can also use the Docker copy and the kubectl copy command to copy binaries into running containers if for some reason you forgot to put bash in there. So remember that. I suspect that I just hit the wrong button again. All right, and then last but not least is a multi-container pod. So remember that containers that are all running in the same pod can also use the same shared volumes. They have the same shared memory space. They have the same shared network stack. This is why security, operations, and networking love running their containers in the same pod as your pod. Sorry, as your container, right? So they want to make sure that they can watch security, they can monitor the network, they can like intercept traffic, they can enforce SSL, they can do metering, rate limiting, whatever. That's why they want to do it, right? So just know that a multi-container pod is typically a security operations plus an application pod. Sometimes you can have multiple application pods inside of a container, but not always. Notice that here you got the main app and you got monitoring and logging. Pretty standard. All right, so in this chapter, we spent time just kind of generally learning that you're going to stick your artifacts into a container. You can actually build those artifacts in the Docker file if you want to. We talked about a Docker file and how to read the Docker documentation, including the various commands like add, copy, from, CMD, entry point. We learned about a little bit about those pieces. We learned that you need a local registry, not just to push a Docker file, but also to, so Kubernetes can grab files itself. We learned 3 methods. One, well, really, one without YAML, one with YAML, and then one that basically just applies YAML. The first 2 are pretty imperative, meaning you use kubectl create. The last one is kubectl apply. We talked about how you can run kubectl exec, and you saw me fumble around there for a second as we got into an Ubuntu container. And then just mentioned the whole concept of multi-container pods, just to make sure that that was cemented properly. Okay. Now the next section is about design, but before we do that, one, we're approaching a little bit of a break time. So I think let's take a short break. When you come back, we're gonna go straight into lab 3, which is gonna be about building a Docker image with a Docker file. And then we are, I think, supposed to, yeah, we're actually gonna do labs, both labs 3 and labs, well, actually, we're gonna do 4 later. So we're gonna do lab 3 now. All right, so for the time being right now, it's 3:50. This is supposed to be a longer break because we've been kind of going at it for 2 hours. So we're gonna actually come back at 4:10. So it's supposed to be a 20-minute break, okay? So come back at—
Quick question, like my session is stuck up by remote desktop. I cannot do anything, so needs to be cleared before I can continue the lab.
I'm sorry, say that again, Sean. I'm not sure what you're saying.
Yeah, my remote desktop session is hanging. Like inside, the inside that remote desktop session, is just hanging. So I couldn't close the running the mini cube or whatever, and then I'm not able to do anything on the remote desktop now.
Okay, so let's troubleshoot it when we get back from the break, okay?
Okay.
All right, we'll see you in about 19 minutes.
Okay.
Wow. Okay, so a couple things to consider. One, let's talk about volumes. So what's interesting here is that the only volumes that really matter are Kubernetes, but we're going to just talk about the others so you can at least be aware of them, right? So inside the containers, inside the pods, they have operating system images that have file systems and binaries in them, but they're not really running the kernel, right? So, you can modify those files in the OS image however you want to. Remember the from scratch versus from Ubuntu versus from Alpine versus from whatever? Your base image is usually going to be based on some kind of operating system. Although if it's clean, it's honestly better, right? And so what happens here is that, actually, that might be a better thing. Hold on one second. Let me show you this really quick. I just realized that I was going to weave this into the class. I hadn't done that yet. Like to say this is actually from running EKS containers on EKS from AWS. So there was something I was going to show you. Fun little things, right? Not that. Components of a container, right? So in the container, every time you have a Docker file and you put instructions in the Docker file, that is going to add a layer. Whenever you change the file system that's inside the container, that's going to add a layer, which those layers get downloaded like layers of a cake whenever you download it from the Docker Hub or whatever registry, right? If not all the layers have changed, it's only going to download the layers that have changed. So this is another reason to run your commands in groupings that affect install Tomcat, update operating system. That way, if you need to change the version of Tomcat, you don't necessarily going to re-download the entire operating system layer that you changed, right? As an example. Now, once you take a container image and you start running it, what happens is that a copy of that container is pulled down and then it's executed. And then when it's executed, what happens is both of them add a thin read-write layer that is ephemeral. This is a fake like almost like scratch file system that uses the host it's sitting on to write files. But the original file system that was created in the container image is there, but any new writes go to this like fake layer, which is discarded when the container is stopped. This is how containers typically work when they're stateless, right? Now, that's the one thing you can say about container images is that they're immutable, but running containers are ephemeral. Now, the way that we get around this kind of thing is that we start adding volumes to the equation. So even though the container has its own operating system, if we want that the file system inside the container to actually work so we can make it persistent, we have to add volumes, or we have to have Kubernetes volumes, which are also called persistent volumes. Docker volumes, are really kind of out of favor. We don't really use them a whole lot anymore because most of the time we're either running Kubernetes locally on our local laptop or we're running Kubernetes out in production. And even Docker Swarm, by the way, uses Kubernetes as its underlying orchestration engine. Obviously, Rancher does the same thing. So does a bunch of others. So we have to attach these little volume files to the containers, and it's usually just a -v. And you can actually mount the host file system. You can mount NFS. You can do CIFS. You can do all kinds of stuff, both with Docker and with Kubernetes. But people have stopped writing drivers for Docker because everybody's using Kubernetes to host their Docker containers. They're not just using plain old Docker. So the volumes typically have a loose association with the pods that they're attached to. In other words, they don't have to live when the pod dies. The volumes don't have to die. That's why we have them, because they're persistent storage, right? So you can support a lot of storage types, also known as volume types, through what's called volume drivers in Kubernetes. They've got drivers for AWS. They've got drivers for Azure. They've got drivers for Google. They've got drivers for NetApp. They've got all kinds of drivers out there for Kubernetes. This, by the way, you can mount multiple volumes in pods at the same time, and you can have multiple pods using the same volume. Word of caution about allowing multiple pods to mount a volume: make sure it's read-only, unless you're using a cluster file system. Now, the specification for volumes in Kubernetes are actually specified in the actual YAML file, right? So, in this, if you look at the spec, there's like a volume declaration. And then what happens is that volume declaration is then used inside the container declaration, meaning here's the volume parameter. Let's load that up. Here's the volume parameter, right, with its name. And in this type, it's actually an empty directory type. So it's actually not the empty directory. Empty dir is a storage class, which just is a scratch directory. And then under the container specification, it's got all these other things, but then it specifies a volume mount that mounts under /temp. It actually mounts the volume called temp volume. Where does it get that from? Well, that's the same thing as it is up here. That's the linkage. So you actually require both sets, because this is going to link to this, and this is going to tell you what type of storage it is. Now, notice there was no real declaration of size, and there are volume types that require a declaration of size. So, just know that that's not always the case. You usually declare a size for your container, for your volume. Like you have to, for example, when you go and ask AWS or Azure or Google for like Elastic Block Store storage, you have to basically, you have to tell it a size. Same here, same here, same here. These do not require like a size declaration, because you're actually mounting a remote system or a local system that has a finite limitation. So it's only when you're calling an external storage system that simulates disk drives that you have to specify a size.
So can the same volume be shared by multiple pods?
Yes.
Okay.
Yeah.
Does it matter which storage it is?
It does, actually. Yeah. And it also matters what file system is on there. As I was just mentioning, if it's not a cluster file system and two, pods try to write to the same file on that file system, it'll corrupt the file system. So at the it'll corrupt the file blocks that are there, right? There'll be contention. So general recommendation is don't do that unless you're going to put the volume into read-only mode. You're only going to mount it inside the pod as read-only.
So I had some confusion on the previous mapping that you were showing on those ML files. Yeah. Could you, sir, please go over one more time? I apologize.
Yeah, absolutely. All right, so this is actually defined lower down in the document. But what happens when it ingests the container specification, it sees that there's a volume mount and it wants to take this particular volume name and mount it right here. So how does it know what that volume is? Well, it goes and looks for a volume definition that says, oh, this is the volume, right? And the type is called empty directory. There could be another storage class here like Azure Disk, right? Or AWS EBS, right? And then it would specify size and other things. So this is not just some random kind of empty dir statement. This is actually a link to the type. It declares the type of storage that it is.
What is that referring to, that empty dir?
It is a storage type.
Right. But like, is that like a local hard drive or something?
Oh yeah. Yeah, it is a local hard drive. Yeah, it's on the host. It's just a scratch volume.
So if it is going to be running on a Kubernetes cluster, is this are we allowed to use this empty dir?
I mean, typically most administrators disable that so you can't do it, but you can use it on your local file system. Remember, empty dir is also listed right here.
Yeah. Sir, what I'm saying that I have not tried it. I'm just asking. So can I use this empty dir to be able to, let's say pod be able to write something to some temp directory or some folder, of the worker node or?
Yep, you can to the worker node, but just so you know, the data will be deleted when the pod crashes.
Oh,
it's not a persistent volume type.
Not persistent volume, gotcha.
Just for crash, right?
Okay.
Don't get me wrong, it's a volume, but it's not a persistent volume.
Yeah. Oh, gotcha. Oh,
right? Because it's temp.
yeah.
And then, so know that you do have to know that like characteristics, right? Obviously, anything that's going to be cloud specific is going to sit on the cloud provider storage subsystem. Config maps, secrets, empty dir, host path, and local are all local disks, right? NFS is obviously a remote storage system, if you've used NFS before. Did that clear up your question?
Yeah, so you did definitely. I think that I was a little bit more, if you have some more insight on NFS, how NFS would work.
Well,
we have in fact a use case where we are using, our customer is using NFS. So I was just curious if you could provide some more information, not right now, or some reference document or something.
There isn't actually much to talk about when it comes to NFS because NFS is 30 years old. So if we go, not that.
Can you use EFS as one of the volume type? AWS EFS?
You can, because it's actually just NFS.
Yeah, it's a replacement, but I think, Sean, I don't know if you heard, there are some issues with using EFS right now with the Kubernetes. They have some DNS. You have to use Route 53 or something like that.
I think one of our tenants, they are using EFS volume.
Yeah. Oh, they are?
Yeah.
Oh, really?
Yeah.
That's good to know. Because my customer...
But we haven't deployed them in prod. We are just, like they're in
started,
the
yeah.
initial
That's good to know.
So we don't know if it works or not.
I see. Well, it looks like it's working somewhere.
I mean, I've deployed it in production on EFS several times in the last
really?
6 months.
Yeah.
So it definitely works. Oh wait, I'm over here in the Kubernetes. I meant to be in the Kubernetes documentation. Sorry. Kubernetes documentation. There we go. So for example, if we go over here and look at volumes, under here is probably where you would find, like, for example, NFS, right? To be mounted in a pod. Unlike empty dir, which is erased when a pod is removed, NFS volumes are obviously not deleted, right? So just so you know, you must have your own NFS server running with the share exporter before you can use it. Some people, by the way, put their NFS server on Kubernetes, which cracks me up, or a separate cluster, but typically NFS is run on its separate set of systems, right? Here's an example of an NFS if you want to see it, like as far as
Oh.
like the different YAML files. So I'll actually share that piece for you. There's just really nothing to it, right? It literally just mounts inside the system. You just have to provide the server and you have to provide permissions, a little bit of like directives on the whole thing, but that's it. So the documentation is all here if you want to see it. If we look at one of the examples, just to drive that home a little bit more. So let's see, would it be a persistent volume? Let's take a look at one of these. So this is a persistent volume, right? In this case, what's happening is that we're defining the actual volume that we're going to use in this particular case. In this, the name is NFS. What's happening is that the server is specified, as you can see here, with a DNS name, and of course mounted on a particular path. Here's some, version if you want, like version 4.2. This is set to read write many, which means it can be used many times, and it looks like it's using 1 megabyte, which means you're going to change that, obviously. So the reason the size doesn't matter is because the NFS share is sharing out an export, right? And the size of that export is actually controlled by the server. It's not controlled by the system. So the size doesn't really matter in that particular case because it's actually controlled by the NFS server. If the NFS server has 100 terabytes of space, you mounting it isn't going to change that. It just gives you access to that whole thing, right? Now, in order to claim a volume, you have to have a persistent volume claim. And in this case, right, here's the name of like how they're defining the claim that's going to be used to mount that storage to claim it as an NFS volume. Let's see, there's server service, there's the replication controller.
So how did the claim, in this example, is the claim referring to the PV file?
What would happen is that the claim would be referred to inside the pod specification.
Right, but is the claim referring to this PV, the persistent volume?
Yeah, the thing that's missing here is the storage class name.
Oh, so
It's not filled out because storage class name is unique to almost every installation. Like like unless it's a managed service provider, they can't predict what your storage class name is, and so they're not going to put it in here.
oh, so
because-
they may be using some provisioner, right? Like dynamic provisioner to provision the persistent volume for this claim.
Well, the funny thing is that for NFS, it's all dynamic,
Yeah.
right?
No,
It's
I'm just
not-
saying
you're
maybe
not-
this storage class, they have to define a storage class then, right?
Right. So in other words, they either have to pass it in some way, maybe in the command line,
Yeah.
or you actually have to define it and say, look, this is the NFS storage class.
Yeah.
And the storage class, as you know, gets defined by the cluster administrator who says, hey, these are the storage classes that we have, right?
Yeah.
Yeah. So
Yeah.
Yeah.
Sir, can you share this site to into the
He has
chat?
put it in the chat.
I already
Oh,
did.
yeah, I did.
Yeah, so if you look at NFS examples under that documentation for NFS, you'll come right to here.
Oh, okay, gotcha.
Yeah.
Thank
Yeah, so this is what I clicked on to get there.
you. Oh, okay, so thank you.
So hope that was helpful.
Oh, it helps a lot. Thank you.
Once it's mounted, by the way, underneath the system, it looks just like any other Linux box that has NFS mounted in it. You can just traverse it. You can grab files off of it. It looks like it's part of the file system, right? Because that's the whole purpose of using NFS. So once it's mounted inside the pod, you just access it as if it's just there. Let's see, the rest of these are all extremely unique, like how EBS works. For example, AWS EFS is the same way, Azure Disk, Azure File, same way. The GCE persistent disks, right, are all act like hard drives. So you have to, now there's two ways to approach this. You can statically define your volumes before you request them, and they have to be of a certain size, or you can just let Kubernetes create the size of volume that you need just by setting up dynamic provisioning, which is how most people do it, instead of trying to pre-create disks, they just allow the cloud controller, which is part of Kubernetes, to request a disk on your behalf at the size that you need. So most of the time, whether you're using EC2 or a managed, like using virtual machines on cloud, or you're using the cloud provider itself, you're just going to access the storage system when you need it. Remember, if you pre-create 100 disks, you're going to pay for those 100 disks. So it's not efficient in cloud for you to use static provisioning. These are some of the cloud resource types that we were just talking about. Nothing really new there. Empty dir was what we saw in the example. You know, it's used to, it's deleted when the pod is removed, but it's used to just like grab some scratch space on the system, on the local host. That's it. What's the size limit? Depends on the disks inside the the local host. If it's only got 8 gigs, you got 8 gigs. If it's 80 gigs, that's what you got. Here, by the way, is the same example with the empty dir volume, but here it is actually put together, right? So we got a pod specification. Again, same thing with the Nginx container. Here's the mount / cache. It's referring to a cache volume, which then refers down below to the actual name cache volume under the volume section. So note that it is inside the / cache directory inside, right, the container in question, or that's being specified. Because even though it's a pod specification, it is underneath the container spec. So Nginx is the one who would mount that inside, right? You, by the way, could get another container in this same pod to mount that same directory if you wanted it to. So it's a good way, by the way, to pass stuff back and forth if you don't want to run across the network. Host path, local volume, NFS volume. NFS we just talked about. Local volume, host path are just local disks, right? Host path actually mounts a directory into the system. A local volume could be a local disk, it could be a directory, it could be a file, but it's represented. It's definitely more localized. So it could be a volume file, it could be a directory file, it could be a disk. Like there could be disk on the host that you make available actually to the containers as well. People do not do that. Just to say this. People generally, as best practice, do not do that kind of thing. Abstract your storage system either at least up to NFS, use Rook, use Minio, use some other storage system, but don't tie it to the host it's running on. You're going to lose a lot of flexibility if you do that. Now, if you're a non-production, do whatever you want. Okay, so here's the order of things, which is a little interesting with around like storage and these kind of components. Okay, so when you want to create storage that you're going to share and make available for pods to use, the one thing that's missing here is the first thing you do is you create a storage class. And that's the administrator. The administrator is going to have an EBS storage class or a hard drive storage class or an NFS storage class. They might even have storage classes that say, this is fast EBS storage. This is slow EBS storage, right? Whether you call it EBS or fast disk, slow disk, SSD disks, fast SSDs, that does not matter, right? What matters is that you have a driver for the storage system that you want Kubernetes to talk to. No driver, no communication, no storage class. Now, Kubernetes has a ridiculous number of storage drivers, so that's unlikely. But that's the first thing. It's not even listed here is that someone's got to create the storage class for you. Now, some of the storage classes are pre-created. Like if you stand up Kubernetes on AWS, I think by default, it creates like a general purpose storage class for you, which is honestly kind of cool, right? So what happens is that then, someone's going to create a claim, right? And that claim is going to basically talk to the storage class in order to get access to a persistent volume. Now, whether that persistent volume is already pre-created because you created it ahead of time as an administrator, or if it's dynamic, what's happening with dynamic is it's going to talk to the storage subsystem and create the size that you're looking for. So the claim asks for the volume, and the volume is provided based on the size that you're looking for. If they don't have a volume that can fit what you're looking for, then they're gonna throw an error, right? Say, I can't create what you're looking for. The same persistent volume can supply space to multiple pods, right? So K8s is going to decide which node to place the persistent volume on based on the node affinity settings, and it's going to place the volume where the pod's going to go. So the pod and the volume presentation are going to all be attached to the same thing, like the same host. So it's not like the storage is going to be on one host and the pod's going to be on another. It's going to chase the pod. If the pod and the storage, if host 1 fails, it's going to remount that storage onto host 2 and then run the pod on host 2, or whatever the host is that's going to run on. So persistent volumes require a storage class, a persistent volume claim, right? And then usually the feedback of a persistent volume to function. Now,
A quick question, sir, on the previous page. Yeah. So the last, but how to say, second to last bullet, the same PB can supply space to multiple pods. So, sir, do you know if this is true for EBS volumes as well? The AWS EBS volumes?
so if they
Somebody
are all,
made some questionable comment and I wasn't sure. So like, so for example, the issue was like the current, customer uses NFS, as a persistent storage, but then they are looking into alternatives. And some, we thought maybe we suggested like EBS CSI driver could be the provisioner and then use the EBS volumes to, create storage class and use the EBS volumes for the persistent storage. And the answer from the customer who has been using this NFS for quite some time, they said, oh, the EBS, you cannot, we can't share, EBS volumes can't be shared by multiple pods, something like that.
actually the limitation is a host limitation, right? So for example, let me draw this out. So let's say that these are virtual machines, right? And they are in AWS. And let's say, for example, that they're split into 3 availability zones, just has a kicker. So 3 availability zones, right? Now on these systems, I've got multiple pods running, right? So, I've got some over here in the first availability zone. I've got some over here in the second and some over here in the third, right? So here's the challenge. EFS will run across all 3 of these availability zones. EFS does not care because EFS is a regional service. So EFS will present the same file system back across all of these availability zones, and it does not care because EFS was designed to be a regional service. The problem here is that EBS can actually mount to multiple file systems. So if we switch this out, we remove EFS. So we're not talking about NFS anymore. And we're talking about EBS. Here's the problem with EBS. EBS only exists on a per availability zone basis. So while it is true that you can actually mount a single EBS volume to multiple hosts in the cluster, it cannot cross availability zone boundaries. So if this pod over here wants that same EBS volume, you can't do it because the disk is over here, right? And you're trying to share it over with these other blue pods because they're all part of the same set. You can't actually do a multi availability zone setup with EBS, but EBS volumes can technically be shared to multiple hosts. So,
But as long as they're in the same AG, then looks like you can do that, right?
You could do it, right? I don't know what the limitation is on the number of hosts that a EBS volume can be attached to. It's not very many, actually. So even though it can do multi-attach, it's not feasible. Plus, it will get corrupted easily. So just, you know, as a general rule of thumb, EBS really isn't good for that. So EFS is, you know, probably going to be your best bet if you want to go across a cluster that goes across the entire region. Because if you can find the clusters to a single region, that violates AWS best practices or any of the cloud provider best practices. They do not want you running in a single data center, which is what you would do there.
Gotcha.
Yeah. Now, could you use ONTAP, which is there's a file service called FSX, which is comparable to EFS. So there's another file service inside of AWS called FSX. You could use that potentially, but you need to check that out because some of those they have some funky network file share options in AWS that just came out. So they've got OpenZFS, they've got ONTAP, they've got FS server for Windows, and they got a file system called Lustre, which is for Linux. But I don't think those are multi-region services, but I couldn't confirm that. EFS is probably your only option right now.
Thank you, sir.
Yeah. So FSX is the name of the other service on Windows. I'm sorry, on AWS as an example. So that one might work. Okay.
And if one was to use EFS, the approach should be the same as the NFS, is that right?
Yeah. Well, actually, oddly enough, I think AWS has an EFS driver that you can use with Kubernetes. So if that doesn't work, though, you can always fall back to NFS because it really is just an NFS mount point. It literally is actually NFS version 4.2.
Oh, okay. Okay.
Yeah, I had to teach on this like last week, and we were in there peeling it out, and it literally said in the documentation, this is NFS 4.2. I was like, okay.
I see. Thank you.
So if you don't want to use the AWS driver, just use NFS. It's not going to change your performance profile. It's going to work fine. And because to say this is that when I mount it on Linux, I don't do anything but just put the NFS client on there. So, and then I just mount the mount point. So it really is just NFS. The steps, by the way, for creating a volume are that you need basically like 3 definitions. Obviously, you need the pod specification. Then you need the persistent volume definition if you're using, particularly if you're using static. And then you need the claim, right? You need all 3 of those, right? You apply the claim first. Is that right? I guess it is. The claim first, then the volume, and then you claim set up the pod, and the pod will call the claim, which will then in turn, call the volume in question. So it's going to provide storage space for what you're looking for. If the volume is predefined, it'll grab it. If it needs to be dynamically created, it'll create it if the driver supports that. Not all of the drivers support dynamic provisioning for storage.
So here, sir, although you're saying the pod, but for all practical purposes, we use deployment, right? Where the pod definition specification is.
That's correct. Stateful set pod. Yeah.
Yeah.
Yeah, that's correct.
Gotcha.
In the pod spec, basically.
Yeah, I got you.
All right. Here, by the way, is persistent volume claim, which we've already seen some of these. By the way, notice that this one has a storage class defined. That storage class name, local storage, is like, that's why I was saying the storage class has to be defined first. If that doesn't exist, none of this is going to work, actually. So hopefully your administrator has defined it. Now, local storage, by the way, is defined by default. So you're going to find that on every Kubernetes installation, unless someone's removed it, which hopefully they have, actually. Now, in this particular case, here's the claim. And notice that it has a number attached to it, 1 GB, right? So what happens is if you apply this file and then do a get, it's going to request 1 GB of local persistent storage from the Kubernetes host that it's running on, right? Here, this is going to define the persistent volume, and it's going to define the capacity of the storage. It's going to be obviously in file system mode. This is only going to mount against one pod before it's discarded. And it's going to delete it once it's done, right? And then it's going to go against the local storage path. And then here's the actual local definition, right? As far as like which disk it's actually using, because it's local storage, right? Since this is defining the actual volume, it's defining the path as well. And then last, as pointed out, is just like in the pod specification, right? What's going to happen is that you're going to define the name of the volume and the claim that the volume is going to claim against. And then what happens is down here in the container specification, you'll see the mount for that LPV storage against this volume. And if we go back up, remember it laid claim to local storage, asking for at least 1 gigabyte of storage. What happens is that when that pod launches, it's going to go check the claim. The claim in turn is going to come over here and grab one of the persistent volumes that's been created ahead of time. If it supports dynamic provisioning, it'll create a volume. You may not even need a persistent volume definition. Yeah, Hardik, go ahead.
Oh, what is the reason for using the claim instead of just specifying the volume you want to use?
You mean it's just saying, hey, I just want to mount this particular volume?
Yeah, like how you do in Docker, you just tell it which volume you want to mount.
In dynamic provisioning, you don't have to specify a persistent volume.
Okay, so for claim, you would only use it when?
So claim is really used for dynamic provisioning.
Okay,
In other words, this is a statically provisioned persistent volume that we're looking at right now. If this was on cloud storage, I would just make the claim and then it would talk to the storage class and it would just make the volume for me. Does that make any sense? And
Yeah, it
this one,
does.
I'm making the volume ahead of time. In dynamic, it makes the volume when I need it.
Okay, got it. Okay.
Yeah. Yeah, because otherwise it's like, why would we do that? Because we like to, remember how I said we like to make things complex?
Yeah.
Yeah, we did. It could be harder. But that's why. All right, so now we're going to talk about dynamic provisioning, right? So in this case, it basically is just going to provision storage automatically when requested by the user. You don't need to pre-provision the storage, right? First, oops, sorry, was somebody talking?
Could you go back to one page? Yeah, here. Sir, okay, so we defined that what you call so here that pod is now trying to use that persistent volume. Gotcha, using this LVP. So, sir, I think one of the questions that I always think is, okay, we defined persistent, like volume or volume claim, and we are referring that in the pod. How the application that this pod is wrapping, how that application leverages this mount, this path, or this volume, how do I write to that, that storage?
Well, I mean, like any programming language, by the way, will allow you to write and manipulate files and directories. You just have to import the right libraries and make the right calls, right? Any of the, like Nginx here, Nginx might be reading a configuration file or feeding out HTML files. So it's just part of the container.
I see.
Yes, I didn't say pod, it's actually part of the container.
Gotcha. So what I'm trying to ask is that, let us say my application, if it was, let's say, some web-based application, let's say some data, you fill out a form, and that web application basically takes that data, stores to a persistent storage. And so, like we were talking earlier about, okay, if you want to write an RDS, then maybe make some, Hibernate or JPA type,
Right.
or JDBC, to write that way.
Yep.
Sorry, here, if my application was just right, because these are, at the end of the day, these are the file systems, right? These are not database per se.
It's just file systems, right? So it's just
File
going to
system.
talk to the file system.
Yeah.
The application is literally running on what it thinks is a virtualized server with a file system on it.
Yeah. And so if that application running, if it was to use this file system, like if I want to open that file and to be able to write, what path I would use, which handle I would use here.
You would
in
just
my
refer
application.
user share nginx HTML/index.html.
That mount path, I see.
Yeah, you would just talk to it
Yeah.
directly, like you were on your own virtual machine.
Gotcha. Excellent. Yeah, that's the question.
And that is an absolute path, right? So to the application, it looks like you're in an absolute path, even though you're really not, right? So you just need to refer to it in the application to that absolute path.
Makes sense. Thank you so much.
Yeah. Okay, so that was all static provisioning. So this is dynamic, right? Now, notice here that, we're defining a storage class. We had to do that before, but that wasn't in there for some reason. So you don't have to pre-create or pre-provision storage. So the first thing you do when you create it is just create your storage class in question, right? Now, if you run on AWS or Azure or Google, they're going to create storage classes for you. You can add more. I highly recommend that you look at them and do that actually. Here is the spec YAML. And notice it looks like, oops, sorry. GCE persistent disk. Wonder where they're running this at, right? That's the GCE persistent disk. I guess it can run standard or SSDs, right? Which is pretty much like all cloud providers, right? So in this case, they're actually going to use a standard hard drive. No. I have rarely used like mechanical hard drives anymore for anything because they just always have caused problems. But regardless, we're going to ignore my personal preferences. And then what happens is that you just need a claim, right? And so in this case, you're going to claim and say, I want, disk storage, which by the way, has to match the storage name that we saw here, which was called disk storage. Because remember, this is the storage class. This is the claim. They have to match. And then what's happened is, and this can be arbitrary. This is just the definition of a claim. Read write once means it's just going to be used one time by one pod, and then it's just going to be picked up, right? That's it. It's defined under resources, and then it's just going to go and make it. That's it. No persistent volume definition is needed. You just need to store. And by the way, the storage class was still needed for the static definition as well, right? But here it's even more important because you need to actually have a subsystem that supports dynamic disks. So all you need if you're going to do a dynamic disk system is you need the storage class, which is you need for both. You need a persistent volume claim, which you need for both, like both the pre-provisioned and the dynamically created storage. But the one thing you don't need with dynamic storage is you do not need the persistent volume definition, because it's just going to create it for you. You still need to put it in the pod or the deployment specification, right? You still need to put it in there, but everything else is the same. I got to tell you, dynamic storage is probably used like 99% of the time. The only time I ever see statically predefined storage is when we are in a non-production environment. So now we're moving out of storage. Any questions about dynamic storage?
No, sir.
Okay, just pausing. All right, let's talk just like about secrets, and then we're going to stop because we got like 9 minutes left, right? We're just going to talk about this last little piece. Actually, let me just check on this really quick. Yeah, it could be a good place to stop. Okay, so we mentioned this already. Secrets are just ways of storing sensitive information. They're under storage because they actually can mount as part of the file system. they also can be just mounted as container environment variables if you want them to be. So, what is that image pool secrets field? Oh, I see what they're saying in that last section. In this last section, by the way, you can actually get Kubernetes to authenticate before it pulls from a private registry. And so you have to use the image pool secrets fields in order to set that up on a per cluster basis. Sorry, not a per cluster basis, on a per like pod basis. So just know that you can actually use secrets to authenticate into systems as well. The way this works is that a secret is just a sensitive piece of information that's actually put into etcd as a Kubernetes object, and then it shows up as a mountable or an environment variable. So it shows up as a file or an environment variable inside the actual container in question. So, you can create a directory from, it's basically a key value set, right? And then you can actually create it from a directory. You can create it from a file. There's lots of different ways to do it. Just to say this, typically it's a YAML file, okay? You can actually just pass literals if you want to as well. Again, no. I mean, if you're manipulating it, sure. But you can actually just use the kubectl command to create a generic secret called dbcreds2. And then you can literally define the user ID, then define the password. And then you could literally just get the secrets if you wanted to. I only usually use literals like this, like the create command, if I'm having to troubleshoot something on the fly. Even then, I'm kind of sloppy about it. So I usually end up just messing with the YAML file and committing that, to reapplying it, right, to change the secret in question. So now secrets, once they are put in as a Kubernetes object, can be mounted, right? So for example, here's the creds vol, here's the mount path. It is read only. And then guess what? This particular dbcreds file, because the volume name is basically specified up here, it's a secret. Before, remember that said empty dir. So what you put under volumes defines the type of storage that it represents. So notice that this is the file-based way of presenting sensitive information to an application. Only people who can see it are the applications inside the pod, right? So here you apply the dbcreds pod, and then you can actually exec into the pod itself, and you could cat this file and see that user ID is Jane IBC. Now, notice, by the way, that every field that you submitted into the secret, whether it was user ID or password, is available, has a file command on the path. So if you put user ID, password, and DNS name, which you wouldn't do because you'd stick that in an external DNS, but you could if you wanted to, and then it would just read the DNS name, the database DNS name, off of the /temp/dbcreds/db database name. DB DNS name, sorry. So remember, this is a file-based way of mounting secrets inside of a container that only it can see. So we're going to switch gears for this for just the last 5 minutes, and then we'll let you go. Hold on. Okay, so one thing I just want to mention, because they didn't show it, and I just want to make sure that you see it. So you can create a secret as a file-based path, but you can also create a secret as a environment variable, right? So notice in this case, they're creating the secret as an environment variable, and then what they're doing is that they're using the in from, right, to define all of the secrets. The data has a container environment variable, right? So up here, they're actually just defining the key, right? It's not actually an environment variable. They're just defining the secret object, right? And username and password, right? Then down here, what they're doing is they're saying, look, I want you to mount the environment variables from this secret reference called my secret, right? which is the same as my secret up here. Notice this is not mounted as a file path. They said, I want to actually get the environment from the secret file. And so inside the container, if you actually echoed out $ username and $ password, it would give you these values. So this allows you to read from environment variables from your application inside the container. You don't have to read any files. And then that way you can just do it that way. So either way, you can take a secret and mount it as a file, or you can mount it as an environment variable inside the container. I just wanted you to see that because this doesn't change. This is the same regardless of whether it's file or environmental base. But here, notice there's no volume definition here. Instead, you're using this environment from command. That way it mounts the environment variables inside the memory space of the container. Does that make sense?
Yes.
So this is using volumes, right? Where secret name is defined. This is using environment variables. Okay. We got 2 minutes. I'm not going to bring up anything else like config maps. We're going to save that for tomorrow. Does anyone have any questions for me or anything else before we go for the night?
So I think that I believe you already answered this. I just want to double check. So this whole persistent volume discussion was about basically making a file-based storage system, making it available to your containerized application. But if you were to use, let us say, the databases like any relational database or NoSQL databases, then we may have to go through what you mentioned earlier about using
External
what was
name.
that? Huh?
External name.
External name, yeah. You have to go that way, right?
You don't have to go that way. You can actually just get the applications to talk directly to the database.
I see. Yeah,
You
yeah,
don't-
yeah.
Right? You don't have
Yeah.
to do external name.
Yeah. But best practice was using that external name. Gotcha.
Right, because then it just looks up at local and then it can just like go through that way. And you have some control over redirection, right?
Yeah.
But if you are doing this, then you don't really need external name because you can just pass the database name, DNS name back to it.
Yeah.
So it just depends on how you want to approach it and how much control you want to have over it. So
Yeah. And we could use, I don't know if you discussed config map here. So
That's
if
next.
you were,
that's next.
that's not, gotcha.
That's
So
tomorrow.
maybe in that config map, we could provide the username, password, and the connect string, or we could use secrets as well, right?
Well, you can. My recommendation is that secrets can actually be encoded. Config maps can't. You could provide everything but the user password in a config map. I would use a secret for the password.
Secret, okay. But the secret gets, as you said before, that gets encoded, right?
It's base64 encoded, but you can encrypt it. You can turn on
Right, but-
encryption for secrets.
Right. No, I'm not saying I don't care about encrypting. I'm just saying, so if the application was to use that username password, can it refer to the encoded version, or it may have to decode into the before using it?
Sorry, it's stored decoded and it's presented decoded.
Oh, okay.
Yeah, it's
Okay,
stored
cool.
decoded. It's presented unencoded, like decoded.
Excellent.
Yeah.
Yeah, I think that's the best way of, that way, you don't have to hard code. Let us say that tomorrow, one of the information changes, we could update new secrets, right? All we have to just do is, make changes to the secret file and push it back to the.
Just word of
cluster.
caution, your application then has to reread the file. So
Oh.
if there's no mechanism for your application to reread the file, then you should probably use the service name instead. You should use external name.
Oh,
That's
oh,
that's the
oh, oh.
distinction, right? If you change an external name, it happens in
Oh.
real time and you change nothing about the configuration of the application, and the application doesn't have to reread configuration. If you use secrets or config maps, the application needs to at least be refreshed to recheck the database username and password or the DNS name change or whatever you've changed. If the application doesn't do that on a regular basis or there's no mechanism for that, then you have to externalize it to an external name service.
Oh, gotcha.
Yeah, that's the distinction. If the developer's like, we don't have time to code that, you're like, don't worry about it. I'll just put it in a service, right?
Yeah.
That's what it's
Yeah.
there for, right?
Yeah. Excellent.
Good.
Thank you, sir.
Absolutely. All right, gentlemen, we are done. So it's 6:02 right now. I'm going to close everything down unless anybody has any questions for me.
Can we continue to do the homework though?
Oh, yeah. Machines are going to
Well,
stay up. Go,
okay.
please, by all means.
Yeah.
So otherwise, I'll see you bright and early tomorrow at 10 Eastern.
Yes, sir.
All right.
Have a good
See you
evening.
then.
Okay.
You
Bye.
too. Have a good night.
Too.
Good night, everyone.
Good night, sir.